Cool, perfect. All right, guys, thank you so much for coming. Really appreciate you guys taking the time. Really excited to be here today. This is kind of my hometown. I lived in San Francisco for 5 years. Now I live in Santa Cruz, so right up the freeway. Really excited to talk to you guys today about building on Ethereum. And real briefly, my name is Kevin Jones. I actually work full-time for NGINX as a technical evangelist. Been there for a while, about 7 years. Now I'm focused on advocacy for Scaffold ETH, which is this awesome toolkit that I'm going to be showing you guys today. I'm a member of the Build Guild, and yeah, Scaffold ETH is just this awesome toolkit that's going to allow you to build on top of Ethereum quickly and easily. I also have a nonprofit that I founded, and I also help out with a Solidity class for Growick. So if you're learning Solidity, it's a good kind of option to get started. And we actually utilize all of Scaffold ETH and a lot of the tooling that I'm going to talk about today. And then I'm also a photographer filmmaker, so you'll see me running around photos after this. I'm shooting the event. So if you want a photo, come grab me. This is all my contact info, by the way. On Twitter, I'm known as CryptoMastery_. And again, if you want to, just find me and we'll chat about stuff later today. Scaffold ETH is, again, it's this awesome toolkit. If you want to get started building on Ethereum, it's really the kind of de facto way to have everything up and running in a localized development environment. These are what you need to get started, really, to be able to check out the repository. Obviously, it's in Git, open source. You need Node.js. You need to have at least version 16 or above. I would recommend just getting the newest version, which is 18. And then you need to have Yarn Package Manager. Scaffold ETH utilizes Yarn because Yarn will install all the dependencies for you, and it will also has all the scripts written for you so that you don't have to remember all of the hard hat commands and React commands and different things that you would do. You can just use simple Yarn commands that are already written for you, right? And so when you check out Scaffold ETH, you're going to get a copy of Hard Hat running locally on your local machine, which is like Ethereum virtual machine, set up and ready to go. And then we also deploy React for you on localhost 3000. And obviously, everything I'm going to be showing you today is in Solidity, okay? What does it look like from the developer standpoint? So obviously, you need to clone the repo. You do the Yarn install. That's going to install all of your dependencies for you. You do a Yarn chain. That's going to spin up your EVM and on a local host. And then it's going to, Yarn start is going to spin up React for you. And then you just do a Yarn deploy, and then it takes a copy of your smart contract, and it pushes it to the blockchain that you're running. And you have this kind of like play ether that's available in Hard Hat to start testing your assumptions on your application, right? If you're looking to kind of test your skills, I would recommend you guys check out Speedrun Ethereum. It's this awesome tool built by Austin Griffith and the Build Guild that allows you to kind of go through these challenges and kind of test your abilities. And when you're done, when you're done with the 4th challenge, you actually get invited to the Build Guild. And I'm going to talk about that in a little bit. If you need help along the way, I'm going to be here, obviously. Also, Austin Griffith is around, so if you find him, he is like a wealth of knowledge and amazing. He's the creator of Scaffold ETH. But this is a good resource. It has the Telegram channel, it has the GitHub, it has the README, it has pretty much everything you need in one contact card, and you can save this to your phone. So don't get lost. The Telegram channel is awesome. There's about 2,000 developers in it that are building on Scaffold ETH. So I'm more of a fan of actually doing and showing how this works in real time. So again, if you do a search on Google, the first thing for Scaffold ETH that's going to come up is going to be the GitHub repository. And all of the steps that I kind of went through earlier and I'm going to go through right now are available here. And then it kind of guides you through of like how you edit your smart contract, how you can edit your React application. And then there's also some resources of how you could learn Solidity if you're just getting started learning Solidity. And then it actually guides you to Speedrun Ethereum, where you can join the Build Guild. So this is some really good documentation, and the link to the Telegram chat is also down here in the bottom. And there's a great docs page as well. So there's a lot of cool integrations that we've done with like the graph, which is a really cool implementation of the graph that runs in Docker. So if you're looking to get a graph bounty, this is a great idea because you can just run your subgraph locally. We also have Tenderly support, like you can actually authenticate your smart contract through them, or ETHScan. And so this is a really good resource as well if you get lost and you just want to kind of read the documentation. If you're getting started, developing on Ethereum and you're learning Solidity, Solidity by example is a really good spot because you can actually go there and kind of copy and paste snippets from various examples into your smart contract and kind of see how those work with Scaffold ETH. And again, this is what speedrun Ethereum looks like. So you can connect your wallet here, and you can connect to MetaMask, and then it will basically, you can go through these quests, and you can submit your work as you do it, and it guides you through. And like the first one that you do is you deploy a simple NFT, then you deploy a staking app, then a token vendor, then a dice game, and you kind of have to hack the dice game. It teaches you a little bit about game theory on Ethereum, and then you get invited to the Build Guild. So that's my shill for the Build Guild, which I highly recommend you guys do that path because there's a lot of cool stuff going in the Build Guild. So far, the Build Guild has streamed over 200 Ether to developers that are building in the ecosystem and doing things for Scaffold ETH. And there's about 584 builders in the system, and there's over 500 builds of Scaffold ETH that allow you to do different things. So an example would be is if you go to the GitHub repo and you come up here to the top, you can actually do a search for whatever build you're looking for. And so like, let's say you wanted to do an NFT. There's like tons of NFT examples. There's like a simple NFT. There's a SVG workshop that you can do. There's a chain link NFT, a buyer mint NFT where you can mint based off the buyer's interest in an NFT. So there's really cool examples for like different standards that are already written for you, right? And so that's a really good starting point for a hackathon because you don't have to do all that work and kind of do all the different things and create the plugins and grab open Zeppelin contracts. They're already there and ready to go. You can just check out that repository and then do a Yarn install and you're set up as a starting point. And that's a perfectly viable starting point for the hackathons as well. Okay, so let's actually get into demo here. So I'm using TMUX, which is just a terminal multiplexer. If you're not familiar, it's really cool because it just allows you to have different windows open. But you can also just do this in different terminal windows. You kind of always have like 3 windows open with Scaffold ETH. I've gone ahead and I've checked out the repository here, and I've also gone ahead and I did the Yarn install and installed all the dependencies. That takes about a minute for you to get up and running. But after you get up and running, you're good to go, and then you can spin up your chain. So we do a Yarn chain, and that's going to spin up a copy of Hardhat, localized Ethereum virtual machine. And then I'm going to come over to the second window, which is in the same directory, and I'm going to do a Yarn start. All right, so Yarn start is actually going to spin up React, and it's going to run it on localhost 3000. That takes about a minute to start up, so we'll just kind of let that sit. And then on the last window is where you'll do your deploy. Okay, so if you do a Yarn deploy, it's going to take a copy of your smart contract, and it's going to push it to Hardhat, deploy it for you. It's going to tell you like the transaction hash, it's going to tell you, or the transaction ID, and it's going to tell you the where it was deployed, what the contract address is. And it also, you'll see that you're starting to see these console logs that are available in Hardhat. So the smart contract comes with it already has Hardhat console enabled, which I'll show in a sec. And so you can print some stuff here and use that as kind of like a debugger, right, for your contract. And then it also tells you how long it took. We can see React started, and we see some read calls that were made to the contract that we have. And first, let's take a look at the smart contract. And I'm going to blow that up in Atom. Any text editor works. If you're using VS Code, it will automatically, I think, spin up a copy of Hardhat, and it will automatically spin up React for you in the terminal window, which is kind of useful. But that can be a little caveat, just you need to know it does that, because you might try to open up another terminal and do that. But that last terminal you'll probably use to do your deploys. Okay, so this is kind of what the structure of Scaffold ETH looks like. There's this packages folder, and that's pretty much where you're primarily going to be working with Scaffold ETH. There's specifically a Hardhat folder, and then inside there's a contract folder, right? And then we have a copy of the your contract, which is just kind of like the hello world starting contract. We can see here that we're defining what version of Solidity to use. We have a license, obviously, and then we are importing the Hardhat console so that we have that console support over here in this terminal. And then you have the ability to do more imports, which we're going to get to in a second. And then this is a real basic smart contract. It's emitting, well, it's setting up an event that keeps track of the address of the sender of the transaction, and it also keeps track of a variable called purpose. And then we have that kind of hello world, building unstoppable apps variable that we set. We have an empty constructor. We're going to get to that in a little bit as well. And then we have just this function that allows us to update that purpose, right? So, and then we have just these are like default so that the smart contract can accept ETH and that there's a fallback function in case that you call the contract with some Ether and don't call a function. It will actually like allow it to store that value, right? So that money doesn't get lost. But really this is kind of what we're going to be looking at is really the set purpose and then the actual function here. So let's look at what it looks like. When you first get into Scaffold ETH, you'll see that there's these tabs. Here in the app home is kind of where you'll build your project. This is where you'll actually start to write like React code. And you can think of it as like an application or a dApp that's inside of Scaffold ETH, right? And so eventually when you launch to production or mainnet, you're gonna probably abstract some of this stuff. And that just kind of makes it easy because you can build your app here. And then it just kind of guides you, like shows you where the contracts are, shows you about variables, stuff like that. But what's the really cool stuff about Scaffold ETH is it has the debug contracts tab. And what this does is it's basically taking your contracts ABI and it's automatically building a UI for you to start testing your assumptions, right? So we can actually come here, if we want to interact with our contract, we can come here and say ETHSF like this, and we can try to send a transaction. It's going to tell me that I don't have any gas, right? I need to pay gas to be able to change the state of that variable. So up here in the right-hand corner, you'll see that there's this funds from the faucet button. You can just quickly grab some funds from Hardhat, and it's going to inject those into your burner wallet. That's another cool thing about Scaffold ETH is it comes with this burner wallet support. So if you open up another tab and go to localhost 3000 again, you'll see that we still have access to that wallet, right? Because that's inside of this browser session. But if I come over here and say new incognito window and go to localhost 3000, then I'm going to get a new blocky dude right here, right? We have this kind of like purple guy, and he doesn't have any funds, but then I also have this kind of green blocky dude that is my prime, like my what I want to use is like my permanent kind of burner account. We could connect MetaMask if we wanted to, right? But it's really easy just to use the burner wallet because you don't have to worry about like nonce errors with MetaMask on a local environment. And then we can also do things here, like we can export the private key if we wanted to. We can import a private key. We can also just send a QR code. So if we want to send some funds on like a test net, which we're going to get to in a sec, we can change that to a test net. Or we can also grab the address, and then we can come here to this kind of like other wallet, which has all of the Hardhat funds, which has about 10,000 ETH, and we can send some funds here. So let's grab, I don't know, like $1,000 in Ether. And we just did that transaction, and now we'll see that our burner wallet updated with some funds from Hardhat. So it's really easy, just you're up and running and ready to start testing. So now if I actually have some funds in my wallet, I can change that state, right? I can pay the gas and do a transaction. But that's not like a super kind of interesting smart contract, so we can kind of see what it would look to start developing some stuff. So let's go back to here, and we already have this function, and it's payable, which is cool, because we can actually like accept some funds there. We don't have a requirement there. We'll get to that. But the first thing you might find out with Solidity or with building dApps is you want to have like some kind of access control. And so let's just set up like a kind of a hacky access control. Let's define an owner, and let's grab this public key from this burner wallet that we have, right? We've got access to the burner wallet, and let's save that, and then we can redeploy. So if you do a yarn deploy again, it's going to see that we have changes to our smart contract. And by the way, if you want to force your deploy, you can do a yarn deploy -reset, and it will force a new instance of your smart contract. And you can keep doing this over and over again, and you'll keep getting new instances of your smart contract. So we can see here, we'll get a new one. And so that really allows you to just reset the smart contract and start testing, your assumptions. And so now we'll see that we have a new variable that we have defined. And now what we can do is say, okay, well, let's say we want to only allow the owner to set this purpose. So we could say something like this: require message.sender, which is the global variable that says who is actually signing the transaction. We'll make sure that it's equal to owner, or we say you are not the owner, like this. Boom, right? I don't know what I'm doing there. All right, save. And then we'll redeploy again, right? And so now if I come over here to this kind of like purple blocky guy, I've got some funds in my faucet, right? Or got some funds from the faucet, and I want to come in here and say, yo, what's up? Like this, and hit send. it's going to tell me you are not the owner, right? So I've been able to kind of set up like access control, really basic access control. But that's actually not the proper way to do access control, so we can actually do it a little different. We can actually, let's get rid of the require statement, and let's get rid of this address, and let's instead do like inheritance of an OpenZeppelin ownable contract. So if you don't know OpenZeppelin is like the de facto standard for doing different implementations or standards. And one of those is ownable. So it has like all that functionality in there for you. So we can say your contract is, and inherit that ownable, like this. And then what we can do is, because it's set up, we're inheriting all of the functions that are inside of this smart contract, then we can actually get access to the modifier, which is a part of ownable, that is only owner. So we can actually grab that modifier, save that there, and then redeploy. And so now we've kind of done the same thing, but we've utilized OpenZeppelin's ownable contract. And we'll see here now that we have like a new function called renounce ownership, which is if you want to like pull out ownership from a contract and make it live forever with no owner. And then we have like the transfer ownership function as well. And we have that address. So we probably don't want, well, first of all, you'll notice that the owner does not match what I think you would want, because you don't have access to this account. This is just some kind of random account. This is actually coming from Hardhat. So Hardhat utilizes the very first account as the deployer account. And we can take a look at what that looks like inside of the deploy script. So right below here, we have the deploy script. And we can see here, this is how we're actually deploying our contract, and we're setting up the settings for that. And you can see right here is we're defining the deployer, which is getting from Hardhat all the named accounts. It uses the first one. And then we can say that it's actually using that deployer. And then we can also see that we could pass arguments as well. So let's say you wanted to name your contract like, I don't know, let's say it's a cat's NFT or something like that. You might be able to pass an argument in here like this, and you could pass that in the constructor. We're not going to do that right now, but it's good to know that is if you want to pass a variable to the constructor, you can do that there. But what I want to show you here is that we get a copy of your contract here. So const your contract, and then we deploy the contract, and we have access to it now inside of JavaScript. And so you'll see here there's automatically a thing that's kind of already written for you here. I'm just going to copy and paste that allows us to call that transfer ownership function. So let's go grab that address here, and then let's paste that in here. So we're going to do the normal deploy. It's going to use that Hardhat account, but then it's going to call the transfer ownership function, right? So we're going to do a deploy reset. Boom, there we go. And so now we see that we have access to the smart contract again. We have access control. But again, it's kind of like not a really interesting thing, because why would we want to have a function that only the owner could call? So I'd rather show you like kind of how you can start using the smart contract as a bank, right? So let's do something like that. Let's open up the smart contract. Let's close the deploy script. And let's set a variable. So we'll take away the only owner modifier, and instead we'll define a price variable. So we'll do a uint public, and we'll call it price, and we'll set it to whatever ether we want. So we'll do 0.001 ether, like this. And what this is going to do is it's just going to create a variable that has the value. And by the way, like I have my ID set up, so it tells me like the calculation of how much ether is to how much whey. So, and I'll get to that in a second, but you could write whey here, or you could write ether. We're going to do ether because it's easier, right, to read. So, and then what we can do is instead do a require statement here that says, all right, let's require that the message value of the smart contract is equal to the price. Otherwise, we're going to say, you are broke, something like that. And save that, and then deploy that. And so now we already had this, and it's important that if you're going to do that with a function, you need to make sure it's payable, but it was already payable. So we know now that we can accept some value on this purpose. So if I come over here now and I want to change this to SF like this, and I try to hit send, it's going to tell me that I haven't sent any money. So now I can come here and I can do 0.001 ether right here, click the little green button. And what this green button does is it just calculates the amount of whey that I need to send in the transaction. So it just multiplies it by 10 to the 18th power. And so anytime you're deploying on or making transactions, you do it in whey. So obviously you wouldn't want your user to have to type out way, so you would do that kind of calculation inside of your application using Ethers.js. There's support for that. And then now if we hit send, it's gonna allow us to do that, right? And so now we see that the smart contract actually has some value, right? It's got $1.65. But at this point, it's kind of black holed. It's stuck in the contract because we have no way to really get the funds out, right? So the next feasible thing would be that you would actually write a withdraw function. So we can do that. We can say function withdraw like this, and we can make it public, and we can do like set a Boolean called success, and otherwise we will not. And then we can do, again, message.sender is the person that's calling the transaction, right? Calling that function. And we can do what's called a call, and we can set the value as the balance of the smart contract. So it's address.this.balance, I believe, and then I think we need to do this. Boom, 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 okay. But we don't want anyone to be able to access all the funds, right? We're owning the smart contract. We want to make some kind of function and variable. So we could actually we can use that only owner like this, right? And save that. But you see what we're doing is we're getting in this kind of mode where we're making changes to our smart contract inside of your Solidity code. You're coming over here, you're deploying your subcontract or your smart contract, and then you're kind of like testing your assumptions, right? And so now we'll see we have this withdraw function. So if I come over here and I'm this kind of like purple blocky dude and I'm using this dApp and I'm like, okay, yo, what's up? I'm gonna send some value. We could just copy this from here to here and send. Cool, I've changed the purpose to yo, what's up? And then I'm like, oh, I wanna grab all those funds. So I can try to say send, and it's gonna tell me that you're not the owner, right? Because we have the access control set up. But if I come over here, it's got funds in there, I can hit that withdraw button, and I was able to withdraw those funds because I own this, this public and private key pair, and I was able to call that smart contract, okay? I wanna show briefly the React code a little bit as well, because I think it's very useful. Real quickly, what I also wanna show is all this stuff that we're doing here is like localhost, right? At some point, you probably want to deploy your application to maybe a testnet, especially if you're in the hackathon and you want to do it to like Polygon, right? You might want to deploy it to Polygon. So right now, we're using the hard hat accounts, right? You wouldn't want to use that if you're deploying to a testnet because the public key or the private key could be compromised. So you would actually want to do what's called yarn run generate on here. And what that's going to do is it's going to spin up, or it's going to create a mnemonic, and it's going to store that in the root of your application here. You can see I have a couple of them here, and so these are the root mnemonics. I'm not going to click on them because there's actually like the mnemonic, the password. And then you can run yarn account like this, and you can basically get a QR code for your account. So it takes your public address, creates a QR account, and then it also goes out and checks the balances of different chains that you're on, right? So what I always do is another cool tool that is actually built by the Build Guild and Austin Griffith is called a Punk Wallet. So I just always have a Punk Wallet on my phone, and then it's got a little scan feature, so I can say allow. And what I can do is right now I could send just by scanning this. Oh, I gotta redo it again. And I just have this preloaded with some like testnet ether. I also have some like Polygon Mumbai stuff on here as well. And so now I have access to that, and I could send some ether to it, right? And then I have a deployer account that is generated, and I'm able to deploy my account. And then if you want to deploy, like I could deploy this right now to, actually let me send some ETH for it first. So we'll go to Goerli, and I'll send, let's see here. Let's do, I don't know, 0.01 ETH. Hit send. All right, looks like it's going. So I was able to send some funds from my wallet. We should be able to see that Goerli has some balance. Oh, not yet. Try it again. No, it's not working. It's pending. So it might take a second, but then we can do what's called a yarn deploy again, but we can choose the network. So we could do --network Goerli like this. And just with that one command, let's see if it actually succeeds. It's going to try to send the transaction. And we are deploying our contract. It looks like it worked. I think it's thinking. Goerli's a little slow today. Usually it's a lot faster. While that's doing that, I also want to show real quick in the UI, you might want to take your React app and update it to a testnet as well. So inside this app.jsx file, and then inside views, so app.jsx is that kind of main component for Scaffold ETH. And if we scroll down, there's just this one section where we can change the default network to Goerli like this, save it, and then we can refresh our app. And so now we should, if it's successfully deployed, which it's not, I'm not sure why it's not deploying. Live demos, sometimes they don't work. Yeah, I'm not sure why it's not working. It could be that I'm not, oh, there it goes, finally went. So I deployed the smart contract to Goerli, and now I have a copy of this smart contract, and I've refreshed my app, and my app is also on Goerli. So now I could actually connect my MetaMask. Let's do it. Let's switch to Goerli and switch the network. So now I have a bunch of Goerli ETH. All right, let's do it here. Let's set the purpose to Scaffold is awesome. Actually, let's do Scaffold ETH like that. And let's make sure we send some value. Boom, send. And then the next step, I'm running out of time, but the next step would be that you would maybe want to ship your app to some other like hosting service, because right now we're running it locally. And you can do that directly through here as well. You can do what's called yarn build, which is going to take a copy of your React app, and it's going to build it and make it optimized. And then you can do a yarn, CD projects, Ethereum, Scaffold ETH. Then you can do a yarn, totally blank right now. You can do a yarn surge, which will put it on a surge endpoint. If you're not familiar with surge, it's kind of like a simple like static hosting service. Or you could also do it to IPFS with yarn IPFS. So you have kind of some options of how you want to deploy your app. But this takes a while to do, so unfortunately it's not going to finish in time. But yeah, that's Scaffold ETH in a nutshell. I do have a couple minutes. I have 1 minute for questions, so I would love to see if you guys have any questions about it. Got to be one question. Come on. Yeah, so there is so under the docs, there's a Tenderly kind of like walkthrough. There's like a video, and it tells you how to verify on Tenderly. Basically, you have to like create this kind of script inside of your deployment script, and I think you have to pass like an API key, I believe, as well, so that the instructions are here. But it's really the only really thing is that you're like authenticating your smart contract through Tenderly. At least I think that's the only current integration. Yeah. You can also do it with EtherScan as well. So there's an EtherScan. EtherScan's a little bit easier because you can just do yarn verify and then pass the network here that you're using. And then you also, I think you have to update, well, you should update your hard hat config also with your API key for EtherScan as well. Yeah, that's a good question. Any other questions? No? Awesome. Thank you guys so much for coming, and I'll be around. So if you need anything, let me know.
Good? Awesome. GM, everyone. Yeah. So I'm David. I'm a product manager from Aave Companies, where I work on our social products, including Lens Protocol. And want to talk to you all today to go a bit under the hood, first into why we felt it was needed to build Lens, and the problem Lens is kind of trying to solve, why blockchain is really the only solution we have, a little bit about the Lens architecture, and then closing out with the Lens API, which is one of the best ways to build with Lens and to build this new class of Web3 apps we call the experience layer. Fancy marketing term. So the problem statement, Web 2 social media is fundamentally broken. Let's think about the login flow for the average app. When you sign into Facebook, you're authenticating to Facebook. They are then kind of looking up your data in the database, taking it and rendering an experience. That data is centralized. It is not portable. Facebook has no incentive to make it portable. It is their monetary stream. All they really want to do is make sure they're getting more data they can then use to monetize further. And Snapchat has the same experience, and LinkedIn has the same experience, and YouTube has the same experience, and TikTok has the same experience, as does RIP Twitter. And the difference of what we're going for with Web3 is we want to kind of make it where you own your content, you bring it to an application so that it is fully portable. And that really makes networks beholden to the users as opposed to users being beholden to the network. In Web3 in a Lens application, which is fundamentally different, you are not just authenticating with the application, but you are bringing the identifier so that it can find your data, so you can bring it your data. I sign into an application by bringing it data, and then and only then can it render experience. The data is in this kind of more public area, which means it is forkable. I can switch experiences at will. Experience can specialize to different types of users. We've already started to see this in the Lens ecosystem. There are apps that specialize for creators, people who create content, and there are apps that are specialized for people who are trying to curate content, and there are apps that are specialized for people trying to consume content. And because it is a shared database that is user-owned, it is not the same company, it is not the same development team building all of those, which causes for better experiences for everyone. So in sum, Web3 social is about bringing power back to the user. So we are going to lower the barrier for developers by making it really easy to build social apps and tools on a composable, decentralized social graph. And the key thing as a developer, you get to focus on the user experience and not customer acquisition. The name Lens is named after this plant, like the Lens calaris. It fertilizes the soil, allowing other plants to grow alongside it. Lens apps want all of the apps in the ecosystem to do well because data generated on one app is available to a different application. As long as you're in the Lens ecosystem, everybody wins. It is a collaborative game, not a zero-sum game. For creators, you get to own the links between yourself and your community, and you are able to move anywhere with ease. Pick the creator tool that you want and distribute to your users at the platform they are using, not just the one where your creator tool lives. So how are we actually building this? Well, we are on a blockchain. We are live on Polygon today. We have a profile NFT. The profile NFT is minted, and it has a publications array that you get to post to. We'll come back to posts in a quick minute. That profile NFT has this thing called a follow logic that emits follow NFTs. So you get a follow NFT by following me, davidev.lens, and it gets dynamically updated with posts. You can always see the latest thing that I have published. The follow NFT includes built-in governance and delegation, so I can set up mini votes for my community. Maybe you want to see me talk more about Lens. Maybe you want to hear me give more hot takes about blockchain. I get to pull my followers for what they want to do. Token IDs are based on the order of following. Bradley in the audience was my first follower. Christina in my audience was my 10th follower. And that has built-in value if I pop off, and they can be able to trade that in the future. Posts, comments, and mirrors, they are part of my profile NFT. They are part of who I am. As I move around with my profile, so does my content come with me. And they have this awesome thing called a collect function, which allows them to be instantly monetized. I can set the rules for how collect NFTs are minted from a publication, and that gives me a way to determine my own, as a creator, determine my own monetization logic. One of the key things and design principles of Lens is we are as agnostic as possible to give as much power to developers. Nowhere in any of this did I specify where you need to store your data. We let you pick if you want IPFS, for example, shout out to the sponsor, ARweave, or you can even go centralized links with S3. We also don't enforce any particular encryption scheme. You as the developer or the user can pick privacy you want, or you can leave things fully public. The option is up to you. We are just providing a minimal spec to help organize blockchain data into a social graph. And so far in our private beta, the community has really loved the Lensverse. We have over 90,000 profiles. They have a closer connectiveness than most of the major social networks. And we are seeing this concept of collect really take off as creators like to experiment with brand new, the collection of user-generated content and micro purchases. And there are tons of different people you can follow, from major content creators like G-Money, to DAOs like Index Cooperative, to blockchains themselves like Polygon. Now over to the Lens API, which is the fastest way to build your own social application or use Lens data at all. Now, to make it clear, Lens is entirely on-chain. Anyone can access the data as they see fit, through your node directly, through a service like Alchemy, or querying something like the graph. However, we all offer our own API. With the Lens API, you don't need to worry about indexing, querying, reorgs, or fetching data. That's all done for you. You don't have to worry about pre-filling contract data or validating it or using weird with-sig methods. Our real goal is to offer something that is easy to approach for development. It looks and feels like a Web 2 GraphQL API. It is simple to interact with the protocol. And there is really not a huge learning curve. You can just focus on the stuff you want to build. In fact, some of the easiest things you can do to build is use a follow-on Lens button, very similar to the kind of ones we have for existing social today, or a sign-in with Lens button. This wraps sign-in with Ethereum, so you're still getting validation that the user owns the address, but additionally, the Lens API will return all of the data it has on that user, their Lens data, their ENS, their POAPs, their proof of humanity or Worldcoin status, and more. And plenty of people are using this today. Here's ETH Global on their homepage, has a link to their Lens profile, as well as a way to follow them through the Lens API. And it's a great way to see content such as this talk and many of the others for ETHSF. So what's next and where are we going? On the middleware layer, we are going to be adding more and more data providers to allow you as devs to build holistic experiences. We already said ENS, POAP, proof of humanity, and Worldcoin. We have many more coming out. If there's a protocol you want, please stop by the table. We really want to build it to help give you guys a powerful development tool for experiences. We have this really awesome concept called Dispatcher and Relay, which allow applications to pay for gas on behalf of the users. It allows seamless onboarding for the masses, and already we have done 4.5 million transactions since we released this feature in June, making the Lens API one of the largest EVM gasless relays. Additionally, we have plenty of teams that are working to extend the Lens contracts to support multi-chain as well as off-chain data to be read on Polygon. Using really powerful protocols such as Layer 0 and Chainlink CCIP and dBridge, you'll be able to read data from multiple chains onto Polygon. So you'll have the ability to say, you can only comment on my post if you hold a Bored Ape. You can only follow me if you hold more than 15 STK Aave. And the real desire is we are trying to power this thing that we call the experience layer, this next generation of applications. The Lens API is stitching together data from Lens, Live Peer, Proof of Humanity, ENS, Worldcoin, POAP, XMTP, Push, and Aave itself in order to provide a data layer for you devs to pick and choose what applications, regardless of chain, to put into the experience that you craft. Because at the end of the day, we have experiences. There are tons of different applications here, but they all want to have different UIs. For Aave, you can go to app.aave.com, Zapper, Rainbow, Instadapp, Coinbase. For Lens, there are a ton live today. LensFriends, Lensta, LensTube, Favor, Orb, Lenster. There are plenty of different UIs that are all using the same contracts under the hood. And for us, this is kind of the evolution of experiences that we think is going to be coming to Web3. Things started out with singular app, single source. You can see that on the Uniswap application, right? The only thing I can do is interact with the Uniswap system of contracts, and it's only on a singular chain. There's more current experiences like the Aave UI, which add in a few apps together. For example, the repay with collateral function stitches in Paraswap to allow for a slightly better experience, but it's still fundamentally single chain. Here's a screenshot from one of the Lens applications, Lenster. It is stitching together data from multiple applications across multiple chains. There's ENS on mainnet, Lens on Polygon, Worldcoin on Polygon, POAP on Gnosis chain, and many more, just in this one frame that's not even the entire screen. And we really think that this is the future of Web3 applications. Additionally, we are upgrading our API to continuously provide powerful features to allow you to create Web2 native feeling experiences. The first thing is we believe that gas is an application cost. AWS bills are part of a business cost for an application, and gas is the Web3 equivalent. We believe that you should be building it into your business model, and therefore our contracts offer metadata as well as permit, as well as this concept called dispatcher, and many of the Lens apps have opted into this UX. Again, 4.5 million gasless transactions through our API, representing an overwhelming majority of Lens usage, and it's not costing a lot. We also have this thing called the Optimistic UI or the Optimistic API. It's something we just released that causes users and apps not to know there is a blockchain running in the background. Apps are given an optimistic assumption that certain right calls succeed. If I follow you on Lens, on a Lens app using the Lens Optimistic API, then any app reading from the Optimistic API will assume the follow succeeds and upgrade, regardless of hard refreshing the session or otherwise. This allows zero wait time to reflect state changes to users and gives an incredible feeling of responsiveness. And we're going to be expanding this to many more calls than the Lens system and hope that other developers use this on their contracts or their SDKs. Lastly, unified queries, APIs that return data from multiple applications across multiple chains. We've already integrated this into our profile function. With a singular call, you can get Lens, POAP, ENS, Worldcoin, POH, Sybil.org data, and more in a singular call. Those contracts are on multiple different chains, including off-chain data, and that is something that we want to expand on more. For developers, you guys deserve contextual data, regardless of where the source chain is. We hope to continue building on that path. So that is what I have to talk about today. Happy to have plenty of time for questions. Awesome. Any questions? If you want to get a Lens profile, you can stop by the booth. We are still in closed beta, but we have tons of spots left, and want to make sure that anyone building today can get one. So the first question is where the contract's deployed. Are we only on Polygon, or will we go multi-chain? So the Lens contracts are open source. They're EVM. They can go anywhere. We have a deployment that we run on Polygon. We also have 2 test nets, both on Polygon Mumbai, one with 0 permissions on it and one that mirrors the mainnet. We are happy on Polygon. It is a chain that is scalable enough to handle the load of Lens. It is a massive, massive number of transactions, and Polygon has shown to be able to hold our scalability. We look forward to continue building there. Yeah, so so we have a creator program where you can email creators@lens.xyz for creator grants, and we have developer grants at ecosystem@lens.xyz. We want to help make sure that you help build awesome tools as part of this ecosystem. So the question was about closed beta. Closed beta for now just means the actual minting of profiles is limited for a variety of reasons. But basically that means that once you have a Lens profile, you can use any of the Lens applications in the ecosystem on mainnet. However, no, until the mint block is removed, you're presumably in closed beta as well. The devs are working their best to do things to relieve it. We are hoping to end it sometime early in the next year. Yeah. Yeah, so the Lens contracts themselves are, and I'll go to kind of the side I think that shows it out. Yeah, so the Lens contracts themselves are built on Polygon, and there are ways in which you can extend them. We call them modules: collect module, follow module, and reference module. These are ways for developers to hook in their own contracts into the Lens system. Lens does not itself specify any bridges for receiving or sending cross-chain data. You can plug in any bridge you want. This follows the same design pattern we used in Aave v3. So we know that there are active teams building integrations with Layer 0. There are teams building integrations with Chainlink CCIP, another one of these messaging bridging protocols, as well as dBridge and Stargate. So Lens is agnostic to the bridging solution used. There are teams, you as the application developer can pick which one you trust. So the roadmap, I think for us, the roadmap is more, we're trying to be this kind of, we want to be the social account, the account structure that is used. We're just here to kind of provide a minimal structure to allow for anyone to build social graph powered applications. This could be as simple as including like a little bit more contextual data when you sign in. So, oh, here's a cover photo, a profile image. I know what people follow, so I can maybe give better recommendations. I can see my positions or my friends' positions or people's who I follow's positions in a DeFi app. For an NFT project, it might be able to, I can recommend what you might want to mint or what you might want to buy in a marketplace based on what you follow. We're here to kind of provide information. And again, because Lens as a protocol is intentionally incomplete, it requires other things to be plugged into it, and so we're here for maximum integration. As we mentioned, I think just this week, we announced integration with XMTP to allow end-to-end encrypted direct messages between Lens profiles, again, showing kind of the extensibility of the project. Awesome. I think I'm at time. XMTP will be getting built into the API. So the API kind of sits on top of, it's not any contract, right? It just is a series of indexers and plugs into various different protocols. And so at some point, XMTP will be built into the API to allow applications to easily pull conversations and other relevant information based on an authenticated user. Yeah. I believe folks from Developer DAO have built a subgraph that you can query. We also do recommend that you use, the API is open, there's no key, there's no nothing to query it, no account needed. It is able to kind of stay up to date much faster than a traditional subgraph to allow you to get real-time information from the social graph itself. Yeah. Yes, the question was about other Web3 social options. I would say that Lens is one of the few true Web3 social protocols that exist. We are directly on-chain. We are directly interoperable with other protocols. Some people have taken the approach of building your own blockchain or keeping your data off-chain entirely. We believe that by being on-chain, by being truly interoperable, by staying committed to Web3 principles, that is kind of the ethos behind Lens, and I don't think we've seen others build in that kind of mindset. Being fully decentralized on-chain. Yeah. Yeah. So we have an integration with ENS, where through the lens.xyz ENS name, you can query any data about, or various data about a Lens profile. So I'm davidev.lens. If I want, I can query using ENS's off-chain resolver, davidev.lens.xyz, and I will pull up my profile picture on Lens, my cover photo, my avatar, my name, location, other various data that I have put into my Lens profile can be queried via ENS if you want an alternative to the API, or if you're already using ENS resolvers in your project. And then there's also, in the Lens API itself, there's an integration that will look up the profile holding a Lens profile and let you know what its ENS is if reverse resolution is set, or what other names resolve to it. To set reverse resolution, I would talk to the ENS team. You can find that out in their documentation. There's a simple contract call you can do on chain. There's a registry. Yeah, so the bounties we have, there's a bounty for integrating the Lens API, either sign with Lens, follow with Lens, the really simple integration. Let me see if I can find that example. And then there are larger prizes for those that build the best kind of social application, the best use case with Lens. Yes, the easiest way to be eligible for prize is just very simply integrate either sign up with Lens, which is a wrapper of sign up with Ethereum, or follow on Lens button. We even have visual examples and simple HTML links. I have to go back and look. I don't know off the top of my head. Awesome. Well, we'll be over at the booth over by the hedges by the main stage. And happy hacking, everyone.
Hello, hello everyone. Thanks for coming. All right, so I'm going to talk about basic and advanced seaport techniques. If you guys aren't aware, seaport is a base protocol that OpenSea has developed, and it's our marketplace that can transfer and handle NFTs and ERC20s. So let's get started. So the way seaport works is you have an order, and an order has two main components to it, an offer and a consideration. An offer is what you are offering, and a consideration is what you expect to receive back for that order. There are two other components. One is called a zone, and one is called a conduit. So a zone can be an external contract that basically gives an approval or disapproval if an order is valid or not, and that can be used several ways. We will go in toward the end of the presentation. And then a conduit is who you're giving your token approvals to help transfer and manage your tokens and the approvals. And the reason that the conduit is nice to have separate than the seaport contract itself is that seaport can be upgraded or changed or moved to another address, and then the conduit can still be used for the approvals, so you don't have to reapprove the conduit if the seaport contract has changed. The seaport contract would just use the same conduit. Two other components of a seaport order. First is the salt, which is kind of like a randomness factor. But lately, what we've been doing is we've been including our 4-byte domain hash, so OpenSea.io. If you Kazakh hash it and take the first 4 bytes, we've been prepending that to the salt, and that helps kind of with order attribution and finding out who is fulfilling or creating the order. And then the counter is an account level thing. Every order you create will be set to your current counter. And if you increment your counter, it's a way to kind of bulk cancel all the orders that are below that counter. So here's a diagram of how seaport kind of works under the hood. It's a little bit complicated, but it goes over at the very top the things we've kind of gone over already, which is the offer and consideration, and the zone and the conduit key, which is a way to reference the conduit is standardized, but the conduit key is like which version of a conduit you're using. Not version, but which like kind of operator that has created the conduit. So all those go into the order, and then when you have an order, you can do several things with it. You can fulfill the order. You can do a match order, which we'll go into, which is kind of like an advanced kind of matching. You can validate the order on-chain, and what that does is you can pay some gas up front to validate it on-chain, and then if someone fulfills that order later, the gas cost to fulfill it is actually cheaper. And then you could cancel an order, which renders it invalid. When you fulfill or match an order, it goes into this left part of the diagram, which is just kind of a series of contracts that help combine and set up the order for the fulfillment. And then as kind of the last part, the order is verified, and the time, the signature, the order status are all verified before the tokens can be transferred. So if you've ever gone to the Seaport repository, we have a set of optimized contracts and a set of reference contracts. So if you're kind of trying to learn what's going on, it's nice to go to the reference contracts and see, to read the code, and it's quite digestible. The optimized contracts use a lot more kind of inline assembly and kind of little tricks to help reduce the kind of gas usage of the contracts. So creating orders. So if you've ever created an order on OpenSea, you sign something like this. And this is kind of what we went over. It's all the components of what an order looks like. It starts with the message and the offer, which in this case, it's a NFT, and the ID of it is ID 31. And then the consideration is, the first consideration item is the one that goes to the owner of the NFT, so that's what they're getting paid. And then the second one is the OpenSea marketplace fee. If there was a creator fee here, the third component of the consideration item would be the creator fee payment. And then you have the start time, end time, zone hash, salt, and conduit key, and the counter, which we kind of went over. So validating order on chain is pretty cool because, as I mentioned, it makes it cheaper to fulfill later. It also emits an event called order validated on chain. So this is something you can do with like contracts. If you have a contract that automatically wants to list the NFT on Seaport, you can do this, and then other people can understand that the order has been kind of like made available to be fulfilled. And then there's EIP 127. So that was EIP 712, which is kind of manually signing an order, which you've probably seen, like with MetaMask, it pops up and you sign it yourself. That's with the EOA. If you have a contract that's signing an order, there's this EIP 1271, which is a standard interface that provides is valid signature, and that's how like a contract can create an order on Seaport. And yep, that allows like smart and multi-sig wallets to create. If you did order validated, that's on chain, you pay a little bit of gas, but if you sent it to the OpenSea API, that would be off chain and it wouldn't cost any gas. And then canceling an order, if you validated on chain, you can cancel it. Even if you created the order off chain, in most cases you still want to cancel it on chain, because if someone found that order or got it later, they could kind of execute it as they want. And then the other option is incrementing the counter, which is the account level kind of nonce. All right, fulfilling orders. So the very kind of basic way to fulfill an order is fulfill order. Fulfiller is the caller, and it takes all the offer items and matches them with consideration items. So this is a very standard way to fulfill an order. The other type of fulfillment is a fulfill basic order. And what this does is it puts certain constraints on what a basic order is. In this case, it's orders that have like a single offer item and have consideration items, and they're all in ERC20 or native. But what this does is allow us to use the call data in the method signature and access that more so that it costs less gas to use. For batch fulfillment, there's fulfill available orders, and you supply an amount of orders, and you supply the max amount you want to fill. This is helpful if you're, for example, you're putting in 10 floor orders, and you say, I'd like up to 5 of these. Then if certain ones are taken during the processing, then you can still kind of allow the transaction to go through. And with the fulfill available orders, you supply a fulfillment array, which optimizes for fewer transfers, which also helps on the gas usage. One kind of advanced method that's available on the contract is match orders, and it's not used very often, but what you can do in this case is a MEV searcher who finds orders that they can match together, and if there's remaining amount after, what you can do is create a consideration item to pay yourself the leftover kind of amounts at the end of the order. If you didn't do that, the amount would just stay with the person who offered it, and they would only be charged the amount that the order was matched. Okay, and then we'll talk a little bit about zones. Zones are really cool because it kind of allows for pre or post order kind of validation or ratification. So some ideas of zones is like a dynamic NFT metadata zone. And what that could be is like, as an experimental concept, if you had an NFT that had metadata that if it changes the value of the NFT itself, then you might want to cancel the orders that are out for the NFT. So if you had a zone that had a kind of a registry of knowing when an NFT's metadata changed, then when Seaport calls out to the zone to ask if the order is valid, then it could deny kind of the parameters of the order based on what the zone itself kind of knows. A compromised NFT registry is another interesting way of creating a zone, because a zone, because it has control to say whether an order is valid or not, if you had a zone that had a registry or a Merkle root of understanding which NFTs may or may not be compromised, then it could, if it was marked as compromised, then it could deny the order and not allow people to transact for it on the marketplace. For front-running resistance, this is another cool idea for a zone. So if you take a zone and you do kind of a commit reveal where you tell the zone, okay, like I'm interested in this Seaport order, I want to kind of like reserve it, then the zone would make sure that only that caller would then, maybe in some time frame, 10 or 15 minutes, only they could complete the order, and then after that period, it could be open again kind of to the public. But that'd be a cool way to kind of create a more kind of a secure way to use like the public mempool, but not allow people to get their NFTs kind of snatched in the process. And then another cool zone would be like Oracle-based price validation. So if you could find an Oracle that has like NFT floor prices or the price of the NFT based on its rarity, then the zone could enforce that if the value is too low, it could deny the order being fulfilled. And sometimes that helps in the case where NFT is stolen and it's listed for much lower than floor, just to kind of get rid of it. This could help protect in those kinds of situations. So a little bit of alpha. We're working on Seaport v2, and one of the concepts in there that we're working on now is an order type that's a contract. So this allows us to do kind of more advanced contracts that can handle orders. Right now, as we kind of went over, an order either has to be signed by an EOA or a contract. And in Seaport v2, we're exploring ideas how it can make contracts more powerful to kind of create orders on the fly based on different parameters and custom logic that a contract itself could hold. So yeah, here's some helpful links. The Seaport repository, the discussions page is a great place where a lot of people have asked questions. And while you guys are here, if you can't find me, you can post questions in there, and we'll try to get to them and help you kind of answer any problems or questions you may have. Seaport.js is also a great kind of accessory utility library. Has a lot of helpers. You know, if you're working in Node or JavaScript, it has a lot of things already built out, like driving order hashes and things that can be helpful utilities. And yeah, there's a Seaport order validator as well. It's an on-chain contract that you can call out to that does like almost 50 to 60 kind of on-chain validations for balances and approvals that we recommend kind of checking out. It's pretty cool. So yeah, thanks for attending. Love to open them up for any questions if you guys have any about Seaport or building on it. And yeah, thanks. Yeah, you could build a zone that's kind of like a pass-through that you could check multiple zones. At the end of the day, it's just Seaport, when it's executing the order, if it's a restricted order, which means that it calls out to the zone. There's a full order and restricted order type, and if it's a restricted, it calls out to the zone. That zone could do calls to other contracts or zones and then come back with one final call. The only caveat is like today on OpenSea, you have to use kind of like the zone that we have, just as like a security thing. We don't allow like anyone to use any zone, but during like these hackathons, we love to see people like building zones, and like there's always like the option of like adding that to some kind of possibility in the future that you could use it on OpenSea itself too. Yeah. Yeah, the Seaport repository should have, so the current zone that's used on OpenSea, I believe it's called like Global Pausable. And the reason it was developed was when Seaport was released in the summer, it was a brand new contract, and just in case something happened, we wanted a way to pause the whole marketplace. And Seaport itself there's no owner, so we wouldn't be able to pause that. But if they're all going through this zone, then we can pause the zone, and that kind of effectively halts Seaport. So that's currently the zone that's being used. And it should be in the repository. So you can see kind of an example of how, and there's a little bit of documentation about zones in the docs folder too. Okay, thanks. Any other questions? Yeah, so I'll be around this weekend. I'm wearing a Seaport shirt now. I'll try to wear like an OpenSea shirt tomorrow. But if you guys are building on Seaport or doing anything with orders, like I'd love to talk and help answer any questions or, yeah, yes. We are a sponsor of this hackathon. I don't think we have any prize levels for this weekend. But yeah. Any questions? Cool. Well, all right. Thank you, everyone. Appreciate it. Oh, app. If you guys would like, you can scan it and get one. I actually kind of want one too. Yeah. Best part.
Now everyone's going to be trying to claim, though. Who can claim faster?
Yeah, they said there's 100 on this one, so I think everyone.
But you might have to refresh because see how it says 0 of 100?
Yeah, okay, I'll refresh it.
Sometimes they like.
Yeah.
The kiosk is like.
All right, looks like someone has claimed it. But yeah, I'll stick around if anyone has any questions. Feel free to come ask.
Sweet. Like the V2 stuff is really interesting. Like with the smart contract stuff, you could go crazy, right?
Yeah, it's yeah, it would be like a whole new world of ways you could kind of create like pools or other types of
Yeah, because I was thinking like this is basically like the thing that sort of kind of does like pseudoswap stuff, right?
Mhm.
All right, GM everyone. My name is Flywell. I'm here to talk to you today about Worldcoin, World ID, and proof of personhood. So just before we get into proof of personhood, I'm going to give a little bit of an introduction to Worldcoin in case you haven't heard of us. Here's the famous orb. Today we're going to talk about World ID. So World ID is a privacy-preserving proof of personhood protocol. What that means is it enables you to prove someone is a human doing something only once without revealing any personal information. So the way we started is crypto is obviously awesome. That's why we're all here. But the value is being captured only by around 2% of the population. So what we wanted to do is bring it to more people in the world. So we started with this premise of what would have happened if Bitcoin started by giving one coin to each person. Of course, this is no longer possible with Bitcoin, but we thought it would be possible with a new token. So that's why we created the Worldcoin token with a limited supply of 10 billion tokens, where every person gets a share of this new token for free, just for the fact of being a person, and then until supply runs out. Of course, the problem we immediately realize is how do you make sure each person only claims their part once? And this is where if someone's able to game the system or abuse it or any type of fraud, then the whole premise falls down. And we realize this is a very existing concept called civil attacks. And this is a concept that's present in a multitude of applications from social governance, and we'll talk about a few more in a bit. So we wanted to create a way where we could solve for the civil attacks in a way that was private, inclusive, and scalable. So we went through all the obvious options, email, KYC, and then we got into biometrics. All of these options we realized weren't enough for either one of these constraints or goals that we had in mind. So, KYC is not really private, it's not inclusive. A lot of people don't have passports or other form of ID. So we got into biometrics. And the problem with biometrics is fingerprint. There's not enough information in the fingerprint to distinguish a billion people or much more. So that was something we couldn't work with. And of course, DNA is logistically too complex and not very private. So that's why we decided to go with the iris, and we created this little device called the orb. What the orb does is it takes a picture of your iris, computes something called an iris code on device, destroys the pictures, and then with that iris code, it's able to check that you're a unique person, not previously registered. So there's no need for contact information, KYC, passport, and any other type of personal information. So this is already quite private, but we realize it may not be enough, especially if you have a single identifier that's tied to your person, then whatever you do with this identifier will be forever tied to you. So we went a little bit deeper, and with something called zero-knowledge proofs, we embedded this as a core part of the protocol. So with this zero-knowledge proofs, what you're able to do is say, I'm a real person, and I have never done whatever action it is before. And you can do this in a completely privacy-preserving way, in a way that if today I use it to claim Worldcoin tokens, and tomorrow I use it to mint an NFT, those are completely separate actions, unable to be traced together. And this is what the Worldcoin protocol is all about. So World ID is privacy first decentralized identity protocol that is based on this concept of a person and is completely open and self-custodial, so anyone can make use of it. The way it works is it looks something like this. Imagine you have this cool application called Mesha where you can get $50 of whatever airdrop you're doing, and you want to make sure that person only claims it once. So you would add the World ID widget that looks something like this, very similar to a CAPTCHA. It's just very intuitive for users. They would get a QR code. You would scan it with your Worldcoin app, and the app would generate this zero knowledge proof that you've verified that you're a unique person and you're only doing this once. So now I'm gonna get into a little bit of the technical details. The protocol is a little bit complex on account of the zero knowledge stuff, but we've abstracted most of this complexity to make it easy to build on top of it. So from a user's perspective first, the user goes to an orb. The orb does this check I mentioned, and then issues a World ID. The user, in the background, what's happening is the Worldcoin app is generating a random secret, and it's showing the public part of that secret to the orb in a QR code. The orb then takes a picture, computes the iris code, checks that it hasn't seen it before, and if you're a unique person, it'll insert the public key into this list of verified identities, which lives on-chain, currently on Polygon, and we're working on bringing it multi-chain. So at this point, this public identity that gets inserted on chain, it's a random number. It has nothing to do with you. It's not connected to your biometrics, and when you use it, it's never gonna be obvious which person in the set of users actually made whatever action it is that you're doing. So this is the flow for how an application can interact with the protocol. So there's essentially two pieces. The application needs to integrate the front-end widget, the CAPTCHA box I showed, so that the user can actually interact with the protocol with their Worldcoin app and generate that zero-knowledge proof. The reason the user needs to do this through the Worldcoin app is because the secret is stored in the user's device, is completely self-custodial, and the app needs to generate this zero-knowledge proof. The other piece is the Worldcoin app will generate this zero-knowledge proof, give it back to your application, and now your application needs to verify that the zero-knowledge proof is actually valid. So to do that, the application needs to call our smart contract with the proof and say, like, is this user actually verified or not? As an alternative, if you're not building something that's on chain, we have an API that abstracts all of this, and you can simply do a traditional REST API request, and we'll call the smart contract for you. The other important piece to keep in mind is, aside from the zero-knowledge proof, the Worldcoin app will give you something called a nullifier hash. So what's cool about this nullifier hash is it's essentially a unique user identifier with the asterisk that you'll get a different nullifier hash for each application. That's how we ensure privacy. So if I claim my Mesha airdrop and I get user ID 1, if I then go and mint an NFT with another project, I'll get user ID 2. So there's never a way to trace users together, But you as developers building an application can always use this ID to ensure a unique person is doing something only once. So if your application requires that someone only does an action once, you need to store this nullifier and compare it whenever a user is executing whatever action it is that you need. So all of this complexity can be very easily abstracted. So you integrate the widget is quite simple. Well, I'll show the code in a second. When the user scans it, they'll see something like this in the Worldcoin app. Is as simple as clicking verify, and that will generate the zero knowledge proof. To load the widget, you simply install this npm package, load it as it's shown there. As you see, you'll need to provide two things. One is the action ID, the other one is the signal. The action ID you get from the Worldcoin developer portal is quite simple. Developer.worldcoin.org. There's links everywhere. I'll share all the links in a slide in a sec. And the signal is this additional security measure that you can make part of the zero knowledge proof to prevent tampering with the proof. So for instance, let's say you want to do an airdrop and you want to make sure that you cannot tamper with the proof so that another person receives the airdrop. If I set the wallet address of the recipient as the signal, and then I'm a malicious user who intercepts your zero knowledge proof and change it to my address, the proof will become invalid. So not all applications require this signal. It depends on your use case, and it can be any arbitrary string. The protection it's giving you is that it hasn't been changed. It's basically an authentication by the user who's generating zero knowledge proof. And then once you receive it, you'll receive this proof along with the nullifier hash, and you can easily verify it by just calling our API, very simple post request, or calling our smart contract. There's a bunch of use cases enabled by Sybil Resistance. Here's only a few. We have some other ideas in our docs if you're looking for inspiration. But you know, there's a lot of possibilities for Sybil Resistance. So here you can go into id.worldcoin.org. You'll find there all the documentation for all the libraries, API, protocol details. If you're particularly curious about the zero knowledge part and the math, there's some details on that too. You can also join us on Discord. We'll be very active during the weekend in both the Worldcoin Discord and ETH Global Discord. So if you have any questions, if you get stuck somewhere, feel free to ping us there. We do want to give a huge shout out to these open source projects that make the protocol possible. So Semaphore is an implementation of zero knowledge circuit. So it's what powers World ID and will let us bring this layer of privacy to the protocol. Hovel we use for the Worldcoin token, and Wallet Connect, which powers the connection between the Worldcoin app and the application. So when you actually are building on this, you'll see the QR code and all of that. It won't look like Wallet Connect, but under the hood, it's using Wallet Connect. And then where we are right now is we launched this protocol, this alpha protocol, about 6-7 months ago. We've been iterating. It's very low key. We've now built different applications, integrations. You can see Worldcoin and Lens integration. If you have a Lens profile, you can actually get it verified with your World ID. You'll get a very nice badge in Lenster, and we'll it'll know that your profile belongs to an actual person. We have a POAP integration, so make sure that a person's only claiming a POAP once. It's pretty cool to prevent farming of POAPs and things like that. And we are now working on making the protocol multi-chain. As I mentioned, it's currently on Polygon. If you're using the protocol on staging or testing mode, it'll be on Mumbai. So choose whether to use production or staging, depending on whether you're building on Polygon mainnet or Mumbai. If you're building outside of the Polygon ecosystem, you can use the API for now. The other thing I forgot to mention is if you wanna test your applications, recommend going to simulator.worldcoin.org. It will basically let you generate any number of random identities on the staging network and let you verify them as if you've gone to an org. Because obviously, if you test in production, if you come to an org, sign up, and then test in production, you're only gonna be able to do it once. So yeah, don't try to use staging. Just to summarize, WorldID is a protocol that solves for Sybil resistance at scale. Private, open source, open protocol, completely self-custody for the user, and very easy to use and implement. If you have any questions, here's the main resource link that you should take a look at. Here you'll find all the documentation and other information around this particular hackathon, information about the prices, anything relevant for this hackathon you can find here. The other thing worth mentioning is for those of you building and submitting a project for the Worldcoin track, be very sure to look at the details for a qualifying submission. In particular, the project needs to be integrated both on the front end and either the back end or the smart contract. So be sure to do both. The reason we do that is if you only integrate this in the front end, then there's not really giving you any protection at all. It needs to be verified in a trusted environment. Otherwise, it loses the value. And finally, we're hiring all around. So if you're interested, come talk to us or worldcoin.org. You can find all of our open positions there. And that's it. Do we have any questions? Yes. So short answer is yes. The protocol will incorporate being able to tie arbitrary data to this concept of a person, and then being able to issue either full assertions or partial assertions. The typical example of I'm over 18, or I'm a citizen of X country. Yes. Yes. So the we are actually very close to open sourcing all of the hardware around the orb. The orb has a bunch of security features to prevent tampering. In essence, the orb has a secure enclave that has a private key. If there's tampering, the key will get destroyed. We can get into more details offline if you want. Yes. Yeah, so that's very much that something that we're working on. You have to physically go to an org to get verified. We can say is on one hand we're exploring options, other options to let you get uh, a measure of civil resistance that won't be as complete as going to an org. And then as a developer, you can choose to rely on something less effective. The other thing is we have a model where um, we distribute this across the globe in a way that is not operated by us. It's operated by entrepreneurs and people that believe in the project, and they get a benefit from operating the orbs, and but there's a whole bidding process to ensure optimal allocation. And right now, with about 20 or something of these, we've signed up like 700,000 people across the globe, over 20 countries. So I'm confident we can get the number up quickly. Yes? Sure. So, full disclaimer, I'm not fully aware of all the details of Polygon ID as of late. However, World ID today is focused on just providing this proof of personhood signal. So it's intended for civil resistance. You get this very high assurance of a unique person because of the biometrics. The Polygon ID, on the other hand, is a more abstract concept around identity and attaching other types of signals. Yep. Yeah, so these public attributes that I'm talking about, they're not part of the protocol yet. The way we're thinking about it is there's going to be some sort of commitment to those attributes public on chain, and then the actual data will live somewhere else up to the developer and the user. So it could be self-custodial on your device. It can be in a decentralized network like Ceramic. It can be on a private database. That's going to be agnostic to the protocol. The protocol will care about the commitment to ensure certain properties around it. Any final questions? Yep. I'm sorry, can you repeat? Ah, yeah, so that is very much ongoing research as well in terms of how your iris changes over time. Um, for many reasons, for different reasons, we currently don't allow children under 18 years old to enroll. And yeah, what it's ongoing research. Yeah, so you can the best place to go for answers is Discord, because we're always gonna be there even if we're not here. So either Worldcoin Discord GG/Worldcoin, or ETH Global, just look for the sponsor Worldcoin channel. And we have a booth here. We'll be around for as much as we can, and you can just come find us. All right. Thank you, everyone.
We good? Hey, can you guys hear me? Hey, GM, everybody. We're gonna make this pretty fun. I'm gonna give you a brief overview of Optimism. So like everything that we're about. We're scaling Ethereum, but we're not just scaling Ethereum's tech. We're scaling its values as well. So unfortunately, I can't edit the notes on the side, so it's gonna be this view. But hope everyone's having a nice day. So before beginning, I just want to talk a little bit about incentive structures. Like, what are we doing here? What is crypto, right? We live in a world of perpetual personal incentives that are pretty individualistic. It's passed down to us from society, you know, go to this college, get this job, do this thing, retire, 401k, all that stuff. And a lot of times these are harmful, right? Like the environment's not doing great. There's a lot of selfish motives in the world. But what crypto allows us to do, very interestingly, is reprogram some of these incentives that we've been taught our whole lives. So there is a mysticism found in blockchains that we don't find in any other technology. The superpower lies in the ability to reprogram incentive models that have been passed down throughout society, right? Like, so enter Ethereum. Ethereum lets you program money. Money lets you program incentives, and incentives lets you program novel social structures. What this means is now anyone can program incentives, right? You don't have to be a king to make a new governance system. You don't have to be chairman of the Fed to make a new monetary policy. You can be in the basement and do this. You don't have to be a Hollywood artist to get exposure for your artwork and get royalties and get paid well, right? So this also lines in with this idea of the unbundling of everything that I think we're seeing in societies currently. So this is a great example of it in the form of the media, right? People magazine, this was like the dominant thing back in the day of everyone would read People magazine, this was the thing. And then came the Kardashians. The Kardashians like took over People magazine. More people were now following this family. And I was like, whoa, okay, great. And then came TikTok influencers. It's like, whoa, anyone can now create content and be seen. And it's this idea of like the unbundling, right? Like now any individual who has a mission, who has like a unique thing they want to express in the world can express it. Through crypto, the similar thing can happen within banks, right? You have like these large institutions that are doing certain things. Now some people who are friends in a basement can program structures that end up having billions of dollars in TVL that people use for banking, right? It's like, goes along the wave of unbundling everything. So I think we all know that like Ethereum is the best city in the world, right? Like everyone wants to be on Ethereum, everyone wants to go there, spend time, but it can get crowded. Like when there's a lot of people in one spot, you get traffic jams, you know, you get like a lot of fuss. How do we fix that? Enter Optimism, right? So just like how big cities need skyscrapers and subways to operate properly, Ethereum needs Optimism, right? We are kind of providing the skyscrapers and the transport layer and everything for Ethereum to scale in a way and make that city that I was mentioning here more livable. But we don't just scale Ethereum's tech, we actually scale its values as well, right? Like how do we do that? Through this thing called retroactive public goods funding. So if you look at the fees that Ethereum generates, just today it generated $5 million. 5 million, like that's a lot, right? But where's this money going? It's mainly, it used to go to miners, now it's going like validators, et cetera. It's going to specific like people in a way, but it's not necessarily going to the community as much as maybe we would like. So with Optimism, this is Optimism sequencer revenue. You know, we're just starting out. Average of about $30,000 a day. Imagine what this can be as Ethereum scales and as L2 scale for the future. Like this will just continue growing up in that trajectory, right? This is just the beginning. 100% of these fees that are generated daily go back towards the community, goes back towards public goods. So we've pioneered this model called retroactive public goods funding, where we essentially, like, if you want to create a public good, you want to do something for free, you want to create educational content for the world, you can do so and know that you'll get retroactively funded by Optimism. One of the things is I think we live in a society that where, like, if you want to do good, you kind of have to be a financial martyr. Like, you want to go help the world, you're going to have to be like, oh, I'm not going to get paid as much as a banker or as an NBA superstar. We think that's wrong. I think we stand a chance doing what we do in this space to reprogram that model, to reprogram that incentive. And we aim to do that by removing the opportunity cost of doing things that benefit the greater good through RPGF. So now who decides where these fees go, right? Like there's all these fees, they're gonna get bigger, we're gonna scale more. Who decides it? Well, around, I think, May, we had our airdrop, and we started our governance collective. So the governance system, which has two houses, gets to decide where these public goods profit, where that network revenue I showed earlier, goes, essentially. So who gets retroactively funded for it, right? This is a little meme. So, initially just like profit motive solves everything. Donation funding, okay, that helps. Quadratic funding, a bit better. Retroactive public good funding, like, let's go, right? So this is a real world example of this. Let's say right now, like, I want to plant trees. Like my contribution to humanity is I want to go and plant trees. Now I walk over, I see a VC, I'm like, hey, VC, can you give me $5,000 to plant some trees? Like, it's for the good of the world. The VC looks at me in the face and laughs at me, right? He's like, why would I do that? Like, there's no return on investment for me. Like, why would I do that? That's the pessimistic world of today. The optimistic world of tomorrow, and today, because we've already done this, is same thing. Now I want $5,000 to plant my trees. I go to a VC and I say, if I do a good job with this, the Optimism Collective is going to retroactively fund me for this. Now a VC is looking at this and being like, that's an interesting model. Like, yes, I'll bet on you, right? Like every investment a venture capitalist makes, for example, is like an investment in a person. Like, oh, maybe they'll succeed. Here they have a clear sign of an outcome where if they succeed, they might get retroactively funded. So that's a real world example of like what RPGF can become. And of course, it's not just limited to planting trees, like everything from building infrastructure to educational content to pretty much everything that's an open source public good. So, we fund public goods through network activity. So as people use Optimism, as you deploy an Optimism or do anything on our network, it goes to feed these fees, then goes to this pot of retroactive funding, then governance votes on where that funding goes. So what's happening with the network? Like, why would you want to use our network, right? Like, what do you want to do, and what can Optimism provide to you? So for that, the state of rollups today. So up and to the right, obviously, like everyone's heard of rollups now. It's growing. A lot of folks are using rollups, right? Like I think we hit almost $6 billion in TVL across all L2s on Ethereum. So there's a lot of traction, and obviously there's a lot of fees that are being generated, as I explained before. But it's cheap, but maybe it's not cheap enough. There'll still be some alt L1s in the world that are like, we're cheaper than you and all of that. Second is like there's a little more decentralization needed, right, with a sequencer, with clients, et cetera. And lastly, like some people might ask, like, what else? Like, what else can a rollup do, except for just scaling this and making it cheaper and faster and all of that? So to address the first one, we do a little fee reduction. So we actually live in a world where we're planning on rollup fees going to 0, and we're going to achieve that through proto-dank sharding. So it's called EIP 4844. And Liam, who's over there, and Proto Lambda, and a bunch of Mofi and a bunch of people from the OP Labs client team have been working on this and trying to do this for everybody, because EIP 4844 actually benefits every single rollup out there. We strongly believe that a rising tide lifts all boats. So EIP 4844, and a quick explanation of that, which I'm going to try to do the best. I don't have my notes on here. So is a toilet metaphor, right? So how can we think about what EIP 4844 is, or EIP 4844? So let's say you're like in line at a crowded festival and you're going to the Ben's bathroom, right? The toilet only has stalls, so regardless if you're like peeing or pooping, you have to use the stall, right? Obviously, a number 1 takes less time than number 2, so it's not hyper efficient for everyone to be using the same stall. You can solve this problem by adding a urinal, and essentially urinals are only used by people who need to pee. At least I hope so. Now the toilet has 2 separate lines you can go to, right? So what does this example actually mean? Well, in this case, the toilet is Ethereum. The toilet stalls are blocks. Poops are transactions. Pee is data. Pee in a stall is call data, and urinals are blobs. And the lines are the fee market. So the upgrade is EIP 4844. It's just essentially making it more efficient, right? Like not having everyone go to the same line, but have certain people go to lines that are more efficient for them. So that was a Twitter thread written by RaiseUETH. It's a pretty good analogy there. So, okay, and second thing we're doing. So this is about multi-client architecture. We are launching Bedrock soon, which essentially is like a pragmatic way for us to start decentralizing. what Bedrock encompasses is theoretically optimal call data submission, consensus and execution, client separation, a microscopic client difference, only 500 lines of code, faster peer-to-peer networking. And all of this is basically in tandem with our idea to not just become EVM equivalent, which we already are, but to become Ethereum equivalent at the very core. This also allows us to easily plug in EIP 4844 when it's ready, which should be soon as well. It also has smarter sync, sequencing, and state submission. So Bedrock is coming out soon, and if you ever want to like read up more on it, we have multiple articles, multiple Twitter threads that explain a bunch. As always, our code is always open source. We build everything openly, so you can access that. Lastly, I think this is something I'm very, very stoked about, is the idea of the OP stack. So the Optimism code base has been forked multiple times. There's been a bunch of rollups that have actually like been using our code base, and we're open source, so we're very much ready for that. That's something that we will always be. But we realized when people forked our code base, they started doing interesting things with it. Like they would mess around with DA layers, they'd add something else, and it would be this like new custom solution using the original like stack that was forked. So we took a long, hard look at that, and we were like, okay, like what if we make that easier? Like what if we make it even easier for someone to do that? And then came the birth of the OP stack. So I think one way to think about it, and this tweet kind of explains it, is you can basically deploy a rollup however you wish with fully customizable features, right? Like you want a ZK rollup that uses like Celestia for a data availability layer, you can go and do that. You want extra throughput, you want to use another data layer, you can go and do that. We're making it as easy to deploy a rollup as plugging in APIs in Web 2. So you want to like bits and pieces, you want to do Bitcoin rollup, like whatever it is, you can actually experiment. And that's what the OP stack enables you to do. It's like we're fully making it very, very easy to run multiple experiments on the future of rollups and whatever you want to create. With that comes the idea of the superchain. So let's say like, the OP stack is there. We have a bunch of different op chains. People are building crazy sorts of rollups. And now you want to connect them. Now you're like, okay, like I want all of this to feed into one larger thing. Luckily, because the way the OP stack is structured, because everyone's using the same stack, is you can actually have atomic composability. So because this idea of shared sequencing where you have all these op chains, they all use like this shared sequencing model, you can basically connect all these op chains together into what we call the superchain. Where this becomes interesting is basically the idea that the hardest thing right now to kind of deploy a rollup or anything in the space is you can do the tech, you can deploy your own chain, you can deploy your own rollup, but then you have to do business development, right? Like you have to like try to get an Aave on board, or you have to get like all these dApps on board. And that takes a lot of time, and that takes a lot of effort, and a lot of times people just want to build cool stuff. So, how do you build cool stuff without having to worry about the whole, like, oh no, like, how do I do this negotiation? How do I do this partnership? The superchain kind of enables that because you can create this op chain however you want. It's connected to all the other op chains. It's connected to Optimism mainnet. You want to do something that's on Optimism mainnet, you can make it really easy for like messages to pass through and basically like interact with stuff that are on other chains. So it literally allows you to make really cool stuff that you've always wanted to do, not have to worry too much about liquidity because everything's connected. But that is a superchain, and it's a work in progress. I think when Bedrock is released, this is going to be easier to actually use. We do have one example of an op chain of sorts that's already come out by the folks at Lattice. It was called OP Craft. It's essentially a full voxel game that's its own blockchain, and it was built on Bedrock. So literally like an entire game that's its own blockchain. It could have, if you were to hack on it, you can make like an AMM that's like in a cave somewhere or something. So that's just like one example. I think the OP stack and the superchain kind of enables multiple avenues, and we kind of have released this thing. And we'll see what can get built on it. But it's allowing for full composability. It's allowing people to run experiments and connecting all of them together into one larger superchain. So I think this is a question that comes around a lot as well. Is like, what is our path to decentralization? So our path to decentralization, I should do this larger, sorry. 2023, we want to create a fault proof which proves L2 Bedrock blocks. We also want to work towards decentralized sequencer selection via OP. Then deploy bonded sequencer using single client fault proof with instant upgrade keys. Sequencer auctions. These are works in progress. Like I wouldn't say it's like hyper-finalized, but these are ways that we are currently might be thinking about it. And then by 2024, deploy bonded sequencer using multi-client fault proof without instant upgrade keys. And then we reach a world where we're a bit more decentralized and can look towards the future. So to kind of summarize a few things here, like what we're really aiming for is solving the blockchain trilemma. And Optimism is getting closer and closer towards being in that middle spot right there. This is our ecosystem at this point. Lots more protocols being added every day. And I think when we look at what I just mentioned with the op chains and the super chain at large, we'll have a lot of different things as well. You name it, like you want a Bitcoin ZK rollup, different DA layer, like all of these things are possible. And we're excited to see what you guys will build. Thank you. Happy to take any questions right now. Yeah. Yeah, so we did a RPGF round. We did a first one, and don't remember the exact list, but you know, Solidity, Aragon, ETHScan. There's a bunch of like public open source things that helped Ethereum, because like we're doing public goods that help both Optimism and Ethereum. Yeah, those in round one. But cool. Yeah, sorry. I can't quite speak on that right now, but like, yeah. Currently, it is a governance token that is used. The power there is, again, like, you know, you have the network fees that I showed you back here. Ethereum does like 5 million a day. You know, rollups are going to scale larger and larger. The fees for our rollups are increasing pretty much every day. Average of like 40K a day, I think, right now. And the governance token basically helps allocate where this funding, because all this fee revenue goes into this pot of RPGF. The token helps like decide where that funding goes retroactively. That's an interesting question. I think, are there Gitcoin folks here? We should have a conversation. Yeah, I'll keep you in the loop, but yeah, that'd be awesome. Cheers. Do you guys have any crazy like op-chain ideas? Like what's like the craziest thing you can think of? Okay, I'm gonna leave it here for a little bit, just in case, you know, just let these questions marinate a bit. Yeah, anything? Yeah, sorry. Yeah, great question. So I think a few things. I believe Nitro might have changed this, but for a really long time, we were the only EVM equivalent rollup. So you know, we had the OVM before, and we were like, okay, like let's move this a little bit. Let's be as equivalent to Ethereum as possible. So we moved towards EVM equivalence, which for any dApp developer just makes it a lot easier to deploy on Optimism. It's just like literally chain ID switching. So that's one. I think the other thing is also the public goods funding route, where you know all of our network fees will go back towards our community. The bet there is if you have a community where you continuously invest in its public infrastructure, you'll basically have a place that's easier to build in, that just has more structure, has more bedrock foundations, that can supercharge the power, like the apps of the future. That's one of the main differences, I'd say. Let's see. Yeah. Also, like one other thing that is different is because of Bedrock, that's going to basically like surcharge a lot of these differences a lot more. Because we allow for multiple clients, that unlocks a whole series of use cases. Like you can have a ZK client on Bedrock, basically, as well. I think we'll have to see. Yeah, it's all really fresh right now. Does that come out yet? Okay, I see. Yeah, Liam's our CEO.
Yeah, basically, like, what's the deal with ZK EVM? I think the whole idea with like the OP stack is that all these things are pretty plug and play. Like, if you want to have a ZK fault proof, whether that's with EVM or whether that's with MIPS or RISC or some other ISA, like, it's kind of whatever you want. There's multiple projects building these things. Like, there's the Hermes one, there's Scrolls, there's RISC Zero doing it for RISC. ZK Sync has like their own kind of custom thing. Like, all these, from my standpoint, eventually these are going to be like solved. It might take a few years until we get like a really performant one that anyone can run. But if it's not open source, I think the community will like reject it. So it'll have to be open source. And the whole idea that we have from our approach is like just focus on the community first, focus on the governance, focus on the funding distribution, and then plug in the proof system later. So from our standpoint, we basically think like whichever one of these ZK approaches wins is the one that we'll use, and we're probably going to start like finding ones that we want to like even start funding or supporting to start competing to be one of the options that people can use for their proof system. So yeah, I think it's kind of weird historically, like how we've ended up in this world where there's like optimistic rollups and ZK rollups is like this competitive thing in this L2 industry, because it's fundamentally we're just building core infrastructure to scale Ethereum, and I think that it's like I think it's a mistake to kind of think of these things as competitive right now. Over the long term, it'll just the whole point, like this kind of technology is going to commoditize, and the interesting thing is going to be the community on top, and what kind of worlds you build with your own chain infrastructure. Which, by the way, is very interesting. Why Cosmos, the Cosmos app chain thesis, I think, is very like worth revisiting. And I think there's probably a world where like on Ethereum we start seeing way more app chains emerge. So I would also look into that as like if you're a hacker trying to figure out what to work on, like you don't necessarily have to go into the app layer. Like there's still like a ton of stuff to work on lower down. Yeah, anyway, sorry, it's a long-winded answer. How will users get onto L2? So I think one big category is the really obvious one, which is like people that could not use Ethereum, that want to use Ethereum, but can't afford it. That class of people, I think they've either like just left, or they went to like Polygon, or maybe they went to Binance Smart Chain, and maybe they are using some application there. But it's not like they're gonna like just like stay there. It's like their favorite place in the world. They're gonna like all of the time shop around for where's the ecosystem going to the future. And so I think that category of people will likely, once it's clear, like, hey, there's an alternative from these like less decentralized, from these centralized chains to use Ethereum again, then I think they might begin to flock over to Optimism because they see this is like a better way to still have the sense of security and decentralization and Ethereum community alignment that they want, and so they'll maybe flock back in. But you're thinking more about the technology. I think that's like, again, kind of all like at this point, like the standard playbook, right? Every exchange should have a deposit and a withdrawal flow. Any on-ramp, off-ramp all over the world. At this point, there's all these companies, they should just have an Optimism integration. On our side, there's like a whole partnerships team just going all over the place, like making sure we have all those integrations. But I think a lot of those are just like existing crypto users. The more interesting thing is, if we actually have the ability to say, hey, Ethereum is cheap, and it works the way you thought it did, it's like less than a penny for anything, then all of a sudden now Ethereum, the product of Ethereum, which is what we're trying to effectively scale with Optimism, will be, in the next bull market particularly, will be like super cheap. And so any of those people that like went to Ethereum and churned, they can actually now like actually stick around. And so it could just be the net new audiences that come in the next bull market. And what that is a big open question, but I think that's probably the more important one, is where will the net new users come from? Yeah, that's a good question. I think the answer, so the question is, how much money should you store on L1 versus on L2? I think I would think of these as like tiers of temperature of your money. Like if your money is really cold, like you're never gonna touch it. You just want it in your like, you want Aave USD, you just don't wanna keep it in one place, like, you know, it's your savings account, it's your money under your mattress kind of situation. Then like probably you wanna keep it on L1 because it's like nothing's gonna change. It's just a net kind of ossified almost system. You're just like, okay. That's like, you know, with Bitcoin, right? It's like not gonna change, so you keep your money there, you can feel pretty safe at night. On the L2s, you want to probably have more of your money that you're gonna use regularly, right? Like it's more of a checking account. It's more of a, you know, maybe once a week, once a month, you kind of use this money for some reason. Either you're leveraging something, you're saving something, you're spending it, you're sending it. Then, you know, L2 should kind of occupy more of the actual human usage. So it might also divide up the users to be more like you have bots and humans on L2, and then you have like large institutions and like you know, hardware wallets on L1. That might be what happens, but it's hard to tell. Yeah. Yeah. There's a few. One interesting one is 4444, which is kind of a history expiry. It's more like the lack of a necessity for clients to store long-term history. Because, like, for example, right now, if you're like the Geth team, or if you're our team also, every time like there's some evolution to Ethereum that changes the way it works, like you're not like upgrading your software, deleting a bunch of the old code. You have to like add new code and also maintain all the old code. So the Geth team has to maintain all of the code from every previous hard fork, and it all has to work perfectly. And that's an enormous amount of technical debt. So 4444 removes a huge amount of technical debt. And the reason why that's important for L2s is that on L2s, you are reusing the client software. At least that's what we're doing, and that's what Arbitrum now is doing too. So you want that software to be minimal and simple and have the minimum possible technical debt. So that's a big one. Another one is Beam Sync. I don't know the number, but Beam Sync is really interesting because it makes your, wow, there's a lot of folks all of a sudden. Beam Sync is really interesting because it enables you to sync a node from a lazy loading perspective. So instead of like syncing block by block or syncing with like Merkle proofs or syncing sort of like through many proofs, you sync as you execute. So like you wanna run a transaction and your EVM trace gets to a point where it's like, hey, I don't have this data. It'll then find other nodes that have the data and then sync it. And the reason why that's important is that the way a fault proof works is that it's the exact same process where like you execute the code and all of a sudden you don't have the data, so you need to get a Merkle proof to show that the data exists in some state root. So it makes the fault proof execution code look identical to the execution code, period. So again, like it lowers the diff even more for writing an L2, which is, again, it's the whole philosophy that we have with the design. I want to mention one more. One just really fast shout out. I think it's also a good hackathon kind of thing to think about, is that eventually the EVM is going to ossify, and you're going to have kind of L2 EVM, right? And so EVM can be, L2s can be an experimental ground for creating your own like version of the EVM. So you can imagine a world where there's like an Optimism with account abstraction, and you can experiment with account abstraction on an L2 because you can actually get the whole ecosystem of the technology around the EIP, like the developer tooling, the Geth changes, the Solidity changes, and so on, the wallet changes, all working on a mainnet production rollup before it's on L1. So, you know, L2 EVM and like the evolution of the EIP process in general is also like a really important category for people to think about. Is there another workshop? Sorry. Okay. Oh, it's Polygon? All right. Go Polygon. All right. Thanks, everyone.
right. How are you guys doing today? Good? That was not excited at like whatsoever. How are you guys doing today? All right, a little bit better. All right, I can work with that. So thank you all for coming to my workshop. We're gonna be talking about on-chain verified credentials with Polygon ID. A little bit about me. Hi, I'm Rahat. I'm the lead developer relations engineer over at Polygon. Previously been front-end engineer, Solidity engineer. I've done some anonymous work for various NFT rugs. I never said that out loud. Indie hacker, Web3 enthusiast. Done some like failed startups in the past, so I can tell you everything that went wrong. I cannot tell you how to succeed. A few places you can find me on Twitter, LinkedIn, GitHub, etc. But right now we're gonna play a game. This image is a claim. The claim is that I am a pixelated punk. Can you verify that these two images are the same? Yes or no? Yes? Am I a pixelated punk? That's not the answer I was looking for. Yes. Okay, cool. So congratulations, you just participated in an IRL version of Polygon ID. What the hell was that, right? Well, what does that actually mean? Before we get into that, a little bit of an introduction onto what Polygon ID actually is. So it's a blockchain native identity system with programmable privacy that empowers people, enables the creation of trusted interactions with Web3 services. I just read a definition for you, so that doesn't actually explain anything to you, right? But what it does is it provides you a way of having a universal identity that you can take with you throughout your Web3 journey, right? You verify something at some point from some type of issuer. An issuer could be some government facility, a DMV issuing you a license, someone giving you some credential saying that you graduated from some college. And you as a person are carrying around that credential. And at some point, someone needs to verify that this credential exists, right? So that's kind of like the flow that I want you to remember as we go through this. So this is called the triangle of trust. So in this case, the case that I showed you before here with the game that we played, the triangle of trust exists this way. There's an issuer called Pixel Portraits. Shout out to Pixel Portraits if you want a NFT of yourself like that. They do this. Pixel Portraits issued me an NFT. It is an image of my likeness as a pixelated punk, right? The ID holder is me. I am holding this NFT. And I asked all of you to compare this ID, this NFT to myself, and let me know if you think it actually is me or not, right? So the way that this is done through Polygon ID is you have your issuer. That issuer issues some sort of claim. It can be, like I said, it can be some type of date of birth credential. It can be something like a diploma. It can be, are you the owner of X item, or whatever it is. That issuer gives you that credential, and you never have to verify that you actually have that credential ever again. Because now you have different verifiers who just look at that credential and have some sort of trust with that issuer, saying, okay, I know this issuer. If this issuer says that this is the actual thing, I believe it. And that is done through a ZK proof. So let's talk about what exactly we're going to be building for today. So many social media platforms require you to be 13 years or older to use them. It could be Instagram. I think Twitter requires that. I don't know. I don't know how it's enforced or if it is enforced. But what we're going to do is we're going to leverage Polygon ID to issue a soul-bound NFT based on a specific age credential. So we're going to issue ourselves a claim. So we're not going to use some third-party claim. We're not going to verify our age or anything. We're just going to issue it to ourselves. And that claim is going to contain our date of birth. We're going to create a smart contract that mints a soul-bound NFT as long as our age is over 13. And there's going to be a front end where anyone with a Polygon ID wallet can claim this NFT. So all of this is contingent upon you folks downloading the Polygon ID wallet app, which is available on the App Store as well as Google Play Store. There will be resources and links to download all of that when you start hacking it on yourselves. But demo and code time. So the first thing I wanted to show you was this Polygon ID platform. So I mentioned that we're going to be issuing the claims to ourselves. So we're not going to go through some third-party issuer and have them like check our ID or do anything. We're just going to do it ourselves just for the sake of this specific workshop. So this platform here, again, links will be sent out in Discord. I will also tweet them out. And this platform here is on a testnet right now. So what you can do once you've gone onto the platform is create a schema. So I'm just going to create a sample schema here. We're going to call it MI13 or older. And the attribute name we'll say is a KYC age credential. You can name it whatever you want. And there are specific data types that are supported right now through these issuing claims. You can have a Boolean, yes or no. You can have a date. So in this case, we're going to be using a date. Or you can have a number. So these are like different things you can think about when you're trying to issue specific claims. So we're just going to use the date because I'm going to be looking at a birthday. So if you want to put in a description, this will be birth date or whatever. For each of these claims, you can add an expiration date if you want to. I'm not going to add one, so I'm going to uncheck this. But now you can either save your schema or save and offer the claim. So we're going to go ahead and save and offer the claim. So this claim has now been created. Now, inside of this attribute for my KYC age credential, I can select a date. I'm not going to use my real birthday, but let's say I was born. I need to be at least 13, right? Okay. All right, we'll just say 1990, February 7th. Okay. I'm not going to put in an expiration date, so this claim is just going to exist forever. I'm going to hit Generate Claim Offer, and this claim is going to be generated. And now we have this link. Copy this link, head over to it, and you'll see that you received a claim offer from Rahat. Rahat is me. I am the person who issued this claim, right? So now you would download your Polygon ID wallet app. You would scan this QR code. And then within your Polygon ID app, you're going to have a specific credential that says you are this specific age, right? So this is, again, a testnet version of you issuing yourself a claim to test out your Polygon dApps. Cool. So now that's the first part. This is a claim. So this is kind of like the same thing as Pixel Portraits giving me an NFT of my punk, right? Rather than a punk, now I'm getting a QR code with a claim that says I am however old I am. Cool. So now let's look at some smart contracts. So all of these contracts are going to be shared and available for you to go through afterwards. So I'll drop them in the Discord as well as on Twitter, so you'll be able to take a look at these. But to get this set up, to actually start using Polygon ID with your smart contracts, there's a couple things you need to do. You're going to have a couple interfaces, libraries, and verifiers. You don't have to write any of this code. You can simply copy and paste from the repositories that are going to be shared with you. But just like a quick thing, if you just go through these, you'll see that these are what's actually powering the ZK proofs and verifiers that are going to be looking at your credential and comparing them within the dApp. All of these, again, are boilerplate code that you can just copy and paste. Where we're going to actually focus on and create our own code is going to be in this ERC721 verifier. So you'll see from line 8 through 10 that I imported all of those libraries. Eventually, what I'm hoping to do maybe later on is create like an NPM package so you can just install and import those rather than copy and pasting them. But that's, as we're iterating and building, that's what you got to do for now. So for this NFT drop, I have imported a couple things from OpenZeppelin. First is going to be the ERC721 URI storage, just to make it easy to set the URI. I am importing counters for the ID of the NFT itself, strings, which is a really cool utility that I'm going to use to convert numbers to strings, which I'll show you in a bit, base 64, which is going to be helpful for actually creating on-chain NFTs. So everything that we do here is going to be completely on-chain. No storage will be used off-chain. So let's take a look at the contract itself. It's an ERC 721 verifier. You can call it whatever you want, but it inherits everything from the ERC 721 URI storage as well as the ZKP verifier. There's a couple of variables here. This is really just keeping track of the addresses that have already minted and making sure that people only mint once. I'm using strings, which I imported from OpenZeppelin for unsigned integers, which basically gives all of my unsigned integers the power to become strings. Counters, which will be for my token IDs. Constructor is just going to deploy the ERC 721, but now we get into the cool part. Before proof submit, this is just some boilerplate code, but what before proof submit is going to do is going to check that the challenge input of the proof is equal to the message.sender. So we want to make sure the person who is actually trying to generate this proof, that is trying to perform this action, is the person who owns this specific proof. So that's what this is taking care of. After proof submit is where the actual magic happens. We first check to make sure that this proof has not been submitted before. They've only done it once. And then inside of this if statement, we actually execute the token mint. So I'm just incrementing the token mint right away, the token ID right away. The token ID from counter generally starts at 0. I just like starting at 1, so I increment it. I get the current token ID, and then I call SafeMint with message.sender, as well as the new item ID. And then I set the token URI using the item ID and this get token URI function that I'm going to show you in a bit. Here, next part, this is what makes this token a soulbound token. This before token transfer is going to override the ERC 721 before token transfer and prevent you from ever actually being able to transfer this token, because your age is your own age and not someone else's. Do not verify your age for someone else. That is a frowned upon action. Two more functions here. Generating the SVG for the token, as well as getting the actual token URI. So I'll just go through this real quick. For generating the SVG, we just have this large SVG code that is going to be encoded and returned as a string and converted to a data image URL. All it is just like a black square that says you are over 13. And I'm using the base 64 encode to encode all of that together. Finally, the actual get token URI, which is going to take your metadata. So this is the metadata that would appear on your NFT. So right now I'm just giving it a name, description, and the image. The name is just going to be 13 check. I'm sorry, I'm really bad at naming things. And the actual token ID. So this is why I brought in the strings package. It gives you this like nice little 2-string utility. Description, verified credential of age over 13, and then the image, which is just going to be this generate SVG for token, which returns a string. Cool. So this part here is nothing specific to Polygon ID. This is simply for minting an on-chain soulbound NFT. Nothing special going on there. Cool. So now we've got this ERC 721 kind of written out for us. There's 2 scripts in here that are going to be super, super important. First of all, deploying your contract, making sure you deploy it. Nothing special here. I'm just taking my contract, deploying it onto Polygon. The next part is going to be this set request script over here. So this is another thing that you'll be able to copy and paste. Most of this is boilerplate code, but there's a couple key things that you can change depending on your use case. So the first thing is going to be the address where your contract was actually deployed. So this is my address that I deployed earlier. And the actual query that you want to do and you want to check for. So the query that I want to check for here is to make sure that the person who supplies their date of birth, that this date of birth is less than or before January 1st, 2009. I think I did the math correctly. That should make you 13. But if it's not, just pretend it is. And you can take a look at this link here, which will show you the ZK query language, which is going to help you actually set up this query. But this operator here with the number 2, I believe it means less than. So it's going to check if like you're less than, your date of birth is less than this. So you have your issuer that gave you that credential. This query is what's going to check that credential and make sure that you're 13 or older. So we've got that. So you run both of those scripts, great. Everything is now on the blockchain. Let's take a look at a front end that actually implements this. I have a little code sandbox here. Cool. Wi-Fi. All right. So this is a very basic React application that I forked from my friend Steph, who did a version of this in Bogota. But here, what we're going to do is claim our soulbound token on Polygon Mumbai. All you have to do is make sure you have your Polygon ID wallet, that you issued yourself a claim that has your date of birth, then you scan this. So rather than me taking out my phone and doing this here and you not being able to see it, I'm going to show you a video of me doing this earlier. This is like, okay, come on Wi-Fi. Right, so this is my Polygon ID wallet. I've opened it up, I already have my claims. I scan the QR code, it generates a proof request. So I hit continue, it's going through creating the cryptographic proof, and it wants to connect to a wallet. So I'm gonna connect it to my MetaMask wallet. And through MetaMask, I am just going to make sure that I connect to the actual website. Once I'm connected to the actual website, it's gonna fully generate the proof to make and do that check. After it does that check, the last thing it needs to do is actually mint the NFT. So we're gonna go back to MetaMask, which will just pop up, and now actually approve the transaction to mint the NFT. So I hit go ahead and confirm that transaction to mint. And once that has been minted, pay some gas, confirm, and it'll finish up the process here. So you'll see over here on my Polygon scan link, about 7 hours ago, I successfully minted this NFT. It was a success. And this is the NFT on OpenSea right now. So on OpenSea testnets, you can check out 13 check number 1, verified 13 or older. You cannot transfer this to anyone else. This is only available in the wallet that this was minted in. But now, what do I do with this, right? I have this specific NFT now. I've with a proof that I am 13 years of age or older. Great, it's wonderful. So now I can do really cool things with it. Token gated access to social apps built on Lens. You had, the whole problem that I mentioned before with Instagram, with Twitter. Do you want to keep sending them your date of birth over and over again on every single platform that you're, on? You're sharing your data across all of these platforms. At times, if they need to do some deeper, verification, maybe you're asked for an ID. Like what is the need to go into all of that and share with them that data? Using this specific NFT, they don't need to know your date of birth. They know that this was issued by Polygon ID through an issuer that they trust. In this case, it was just us, but if it was done through an issuer they trust, then they know that they don't need access to your information. They know that you own this NFT, you get access to the platform. You never have to share your actual age with social media platforms ever again, just a verification of the fact that you're old enough. So you're only sharing information that they need to know and nothing more than that. And you own your data and you're not actually going forward and sharing all of it. So I wanted to make sure you have some additional resources. This is, a new thing, a new concept to kind of like learn. These will also be put into the Discord. So first, definitely check out Steph's original Polygon ID workshop from ETH Bogota. She's here, and you can definitely dive a little bit deeper into that as well. There are 2 GitHub repos from Steph and one of our teammates, Manny. Both of those go into using this with ERC20 tokens, as well as another example with NFTs. Manny's GitHub also lists some potential error messages, common things that you might run into while you're going through and building all of this. So definitely take a look at that. And the last thing will be the Polygon ID docs and tutorials that you definitely want to go through. So while going through this, I remember I forgot to actually go over one thing. So we're going to go back to the front end, just so you're aware of that, what that one thing is. Very vital thing for you to actually do this. So let's go back. Where's ARC? Okay. So how did I actually make this QR code work? I never told you that part. So in this React application, we're just using this QR code generator to generate a proof request, which is just going to be a JSON object with a bunch of information. It's going to be a bunch of it. Again, it's going to be boilerplate code. Once you go to this link over here, it'll tell you exactly what you need to fill out. Some of it is going to be information from the claim that you issued. So you have to make sure you have that in there properly, as well as the actual deployed contract address, which I added up here and used as a variable down here. But all of this information needs to be put into your QR code. So you take this JSON, put it into your QR code, and that's how this is generated. You scan that with your Polygon ID wallet. It reads all of this information, including the contract address, as well as the type of credential that it needs to verify. And that's what's going to kick off the whole process for doing the NFT mint. So all of that is going to be available on this link over here on the Polygon ID GitHub, which will go through the query language on how to create this specific query. Throughout the weekend, myself and Steph will also be here, so we'll be able to help you with any further questions that you might have as well. Again, these are some of the resources. I will send them in the Discord after this so that you have them and you don't have to take a picture and like retype it or whatever. I'll also send these slides. Recording of this will also be available. If you did enjoy this workshop, please let us know. We're at 0x Polygon Devs. I'm also at Rahat Codes. And there's a couple minutes left for questions. Anyone has? Yes. Yeah, I mean, ultimately the security of your wallet is up to you. So that does not solve for that specific problem. There are cool things in the works like account abstraction and things like that that'll hopefully help with things like that. So that might be a good way to combine Polygon ID with like an account abstraction project. So right now, this is all on testnet. On mainnet, there is an implementation with the Polygon DAO. And through the Polygon DAO, there's verification for like age credentials and things like that. So that is possible. So as we roll out and put this into mainnet, we'll be able to give you more information on that. Yeah. So in this specific case, I created claims myself, just like to do the test. But the claims would have to be coming from trusted issuers, right? So whoever is doing the verification has to trust this issuer. So if you're trying to go on to like a social media platform, they might have specific issuers that they work with. So they might say, get yourself verified through this. And if they say that you're good, right? So that kind of like falls into that triangle of trust. Yeah, so a lot of them will have to be centralized just because of the nature of like what they're verifying. Like if they're verifying like your passport ID for like, proof of personhood or verification of date of birth, That all exists on centralized servers, so it has to be from a centralized kind of like source of truth. But what we're doing here is like taking that verification and allowing you to kind of control where it goes and only share the information with like specific platforms that need it. So the Polygon ID wallet is really just for the holding your claims, but the actual like transactions and everything that happens would happen in any wallet you choose. So in the demo I showed, it went to my MetaMask wallet. So that side of things, the actual transactions will be with whatever wallet you have. The Polygon ID wallet is really for holding your claims. Cool. Question here? Yeah, something like that would definitely be a really good use case. Yeah. Yep. Mhm. Yeah. I don't know the specifics around that, but I think that's a very good thing to be working on. I don't know like the roadmap for like how verifiers will work in the future. Yeah. Cool. Any other questions? No, they just need to trust that the issuer will do their job correctly. Yeah, the example I showed here was like doing some like on-chain verification with that NFT. But you could, bring in something like ENS, like this is a person verified to have some ENS credential or whatever, and bring that as like a claim. So that as we kind of like build out the issuer side of things, these are different use cases you could potentially bring in. Cool. Well, thank you all for coming out today. We'll be around for any further questions. We also have like exclusive hoodies since you stayed all the way till the end, if you want to grab some. We have them outside. I lied. Here,
How are we doing with time? Did you say we're a bit behind? Okay. Sure. All right, we'll kick this off. Cool. Well, welcome everybody. This is the SKALE workshop. And today I'll be speaking, John Frost. I'm the solutions engineer. I run the validators, help with the dApp integration and partner integrations. Part of this presentation is also going to be with Sawyer, who's over there to the left. He's part of the SKALE team. He's a software engineer. And in the room, we've also got some SKALE team members. So maybe you guys can put your hands up. And I'm going to quickly go around. So we've got Jack, we've got Jace, Nicole, Fabio. I'm sorry if someone's behind that light because I can't see you. There's Connor. And yeah, so that if you guys have any questions, by all means, come to speak to any of the team members or go to the booth as well. Straight after this, we actually have a lightning talk from, well, actually, no, 30 minutes after this, we've got a lightning talk from Jack. So I don't want to steal his thunder on SKALE and its overview, but essentially SKALE is a proof-of-stake decentralized infrastructure platform that is EVM compatible. There's a lot of key features, like zero gas fees, it's very modular, it's very flexible, and so forth. But the agenda, we're deciding upon what we're going to discuss today, and I just wanted to showcase a couple of things. The title is How to Leverage SKALE Tools to Build Zero Gas Fee dApps. What I wanted to do is just showcase how easy it is to mint and deploy NFTs on the SKALE chain. So I'll just do a deploy and mint. After that, I'll showcase how you can actually put it up to the file storage. We've got a GUI for that, just uploading the ones that I've minted, and I've got some traits. Metaport, so that is essentially going from SKALE chain to SKALE chain, which is very new, just released. And the second part is Sawyer, where he'll talk about the S-Field station, the SKALE chain UI dashboard, which is also very new, and we'll follow that up with Q&A. So let's get to the good stuff as well. We've got plenty of prizes here, and if you're going to impress anyone, you got Jace and Connor, who are the judges. Jace loves coffee, Connor espresso martini. Prizes, we've got 5,000, so that is for one dApp. Then we've got 8,000 for Metaverse Gaming NFT prizes, 2,000 for partners, so that can be the Graph Connects, any of our partners in our ecosystem. And then we've got 5,000 for the prize pool, which will be evenly divided among the teams. But I just wanted to highlight some important links as you guys kind of like go through hacking, and it's, specifically on obviously SKALE. We've got the hackathon SKALE.network that includes like the documentation, some endpoints, S-Fuel and file storage. SKALE Space, that is essentially like developer docs. That's just kind of our general website, the blog, and you've also got Discord, where you can just reach out to us. You've got GitHub, so that's the SKALE network, so that's just the public repos with a lot of readmes, and then you've also got our stats page, which is a lot of statistics and metrics that keep going up, which is awesome. So let's kind of kick this off. So this is the demo that I wanted to showcase today. I'm going to close this presentation down and just showcase two things here. So on the left, we've got Block Scout, which is a block explorer. And on the right-hand side, we've got the repo that I actually created for this event. And you guys can use it if you want to. The intended use, as I've kind of written here, is for this event. Sure, we can use it, you can use it for other events, but the project setup, there's some requirements here. You can clone the SKALE demo, just NPM packages, setting the environment variables there, creating a private key, sfuel, compile, deploy, and then you're essentially just going to do the minting. So it's a 5-step process, easy to get up and running for you. So instead of making you guys watch me download all these packages and whatnot, I've already kind of gone ahead and updated my env. You can see here that I've already done the deployment of the address right here. And just below it, what I'm going to do is essentially just mint some tokens. So what we'll do is I'll just run this, and you can see, and I'll bring up the Explorer on the left side, and essentially you can see, look at these transactions are coming through right here. And what I've done is used MTM multi-transaction mode and essentially minted these, and you can see them in the Block Explorer. So that's the creation, so I'm just going to refresh this, and then essentially what it's doing here is you can actually see, I'll refresh it again, and then you can see there'll be essentially, there's 31 here, and let me open this up a little bit more, and it'll be on the blocks, and then you'll essentially see the 100 that's there. So you can see I just minted 100 tokens. That's how easy it is and how fast it is to essentially deploy and mint some tokens. On the actual minting, I actually created some special traits. You can add whatever you guys want to those. Essentially use your own. And one awesome thing that not many people know about SKALE, and I got it on the shirt here too, is our file storage. So you can upload any asset you want to the actual SKALE chain yourself. This is, a simple kind of overview of file storage and how it's, decentralized, and it tells you about the space that you've got, and it walks you through the npm install. But just on the right-hand side, you can see like how you can upload files, delete files, create directories, and so forth. So I did go ahead before, and this is the GUI that we just released as well. So you can go here, you can essentially upload files here, and what I did is one of the NFTs I minted is you just select it here, and you can actually see this one there. And then this is just essentially the traits and whatnot. So I brought that up before, and you can actually see, hey, that's the color, that's the stamina, and so forth. So that was the second part of the second part of the talk, and then I'm going into the third part, which is the SKALE chain to SKALE chain, and this is the Metaport. Again, this is something fresh and new that we've just released. This is our staging environment, as you can see, staging v3. Right here, we've got the dog chain, which is essentially the origin chain, and then the cat chain, which is the receiver, essentially cloned there. And you can click on these. You've got the Explorer, you've got all the RPC, all that jazz. You can see MTM's enabled up here. And I'll go back here. It's going to be exactly the same for the cat, the receiver. And you guys can go here. So metaport.demo SKALE nodes, and you guys can play around with this. We've got a lot of cool stuff on the left-hand side here. Sandbox, so that essentially just opens up the widget for you to play around with. All this is just an interface whereby your application, and you can implement the widget, which I'll show you in a second, onto your application. But you've got different colors, different, whatever color you prefer there. This one, I'm keeping on the NFT theme. You can see ERC 721, 1155 there. But I didn't actually highlight these, so this is SKALE chain to SKALE chain. I'll click on these. So you can just play around with these. You can go to the sandbox at the top. You can do the wrapped ETH there. But yeah, going back here, for example, I am going to move from dog chain to cat chain. And you can do it back as well. But you can see there's the collection. I've got 7 out of 100 there. If I do, for example, 2, and I want to move it, what you can see on the right-hand side is the widget. So this automatically fills the chains in here, and then also in the metals, you can see this is token ID 1, token ID 2, token ID 3, and the amount. See, I just put in 2, it automatically does 2, and then I just do the transfer and I sign for this confirm. And then what we can do is I'll refresh this, and what you can see it there, right there. So you can see 2, that was the token ID 1. So you can see that's transferred to SKALE chain. And the awesome thing is here, you can see the post incoming messages here, and you can see the 2 and then 1. And if you want to, you could just send it back and essentially do the same process there. But if you guys just want to play around with it, use the sandbox and so forth. Lastly, I just wanted to highlight the repo for the Metaport that you guys can use. And this is the hackathon SKALE.network that you guys can use here. Jace did a great job of just updating this recently. It just talks about deploying on SKALE, using file storage, and you just put in your endpoint there and your wallet, and you can get S-Fuel and reserve some space. And Sawyer, I don't want to steal your thunder. This is essentially moving over to you with the S-Fuel station, and I wanted to lastly just show some awesome stats that we've got that's just refreshing here. You can see anyone can go to this. It's not as if it's internal. You can see the total transaction count, the total gas fees, and that's going back to the initial point where SKALE is gas free. So yeah, to just recap, what we did was we essentially deployed, we minted some NFTs, we moved those NFTs to file storage. You could see it in the GUI, and then you saw the Metaport where I was just moving the NFTs between 2 different chains. So I'll end it there on my half, and then Sawyer will take it away with the rest of the community tools. And we'll have Q&A at the end, and I'm going to invite Connor up to help with that as well.
All right, everybody. I am Sawyer. As John mentioned, I am part of the solutions engineering team with SKALE, and I'm going to follow up on the amazing kind of technical pieces available to the SKALE network and talk a little bit more about the tooling that's available and how you can use it to make amazing zero gas fee dApps on SKALE. So to start off, user experience is key, right? So blockchain, everybody knows, whether you're a user or a developer, it's really complicated still. A lot of people are doing amazing things to simplify that, but ultimately, sorry guys, I flipped the head on accident. Simple onboarding is a common trait in Web 2. Not so much for Web 3. Anybody ever asked their parent or their grandmother to use MetaMask? It's not so simple. Additionally, Web 2, whether it's the Twitters or different Gmails and stuff like that, generally they're free to use, right? Or at least they have a freemium option. And lastly, they use just common things to onboard, whether it's email or text, right? You get your codes through things that everybody has, or at least most people in the world have them. Web 3, on the other hand, most blockchains require constant payment just for usage, right? Gas fees and all sorts of things there, you're constantly getting chipped away at. Additionally, while we have this bleeding edge technology, crypto wallets are not really friendly to the average user. And so what I'm going to talk about kind of throughout the rest of this is one of the key components of SKALE, which is not just the tooling in general, but more specifically S-Fuel. So S-Fuel is, as many of the SKALE people know, one of the things I love because I've worked on it quite a bit. And you can actually see that top left picture is the S-Fuel station that John alluded to earlier. And it's kind of the precursor to S-Fuel. So S-Fuel is not gas. It's actually stands for SKALE fuel. And it effectively represents the ability for any user to transact on any SKALE chain entirely for free. They do not have to pay money. And that's a really, really big statement. Following that up with SKALE's infinite scalability, you effectively have the ability for any user anywhere in the world to use a SKALE chain entirely for free at any time, as long as the service is there and they're running on SKALE. That being said, getting started with SKALE, right, is kind of similar to many other blockchains, except we have some way cooler tools, in my opinion, because I built a lot of them. The file storage UI, I did not build, but the SFuel station and the SKALE chain UI, I did build the original versions, and I'm very proud of them, and I'm going to talk a little bit about them here in greater detail. So the SFuel station, and I have a little video here. We're going to hopefully make this work, maybe. There we go. Okay, it's running. So you can see MetaMask or Rainbow Kit is popping up, and I'm automatically connected. Just like that, my wallet's connected. I click Fuel Wallet, which is that little black box. My address is in the field, and we should see a spinning wheel in a second. There might be a little delay. There we go. And now I'm changing the theme because I love dark mode because I'm a developer. But if there's light mode, or if you like light mode, it's there for you. And there we go. We can actually see, I know it's a little bit small, apologize, but that little green text on the bottom was the list of chains that you actually just got filled up on with SFuel. It was CryptoBlades, SKALE Community Chain, the Calypso NFT Hub, Europa Liquidity Hub, and the Razor Network. And so what this basically means is, as a user, right, instead of having to go to Coinbase or go through a fiat on-ramp or Binance, whatever it may be, purchase Ethereum or some other token, transfer it out to a wallet, and then get started with DeFi or NFT marketplaces, you can just go to the SFuel station, connect your wallet, fill up, and go start using one of these dApps that does not require you to effectively be blocked by a paywall, because SKALE basically removes that blocker, right? It's a community tool, which is really amazing. It takes about 3 clicks, fully open source, and overall, it's just kind of that first step in a really smooth onboarding experience to the SKALE network. That's kind of the user experience side. Now, on the other side here, there we go, is the SKALE chain UI, right? So clean user experience, really important for a blockchain. But on the flip side, I'm a developer. Building on most blockchains is really, really difficult. Most of the tools are either lacking in documentation, they're half-baked, they don't work, whatever it may be. I won't lie, the SKALE chain UI is a little bit half-baked. I'm the one that built it. It's currently undergoing an entire facelift, which I'll show you some mock-ups in a second. But I'm going to use a couple analogies here to kind of explain why this tool is so important to the SKALE ecosystem. SKALE chains, you can have a lot of them. You can technically have an infinite amount of them. And they can all connect together. And the cool part is they're actually effectively dApp chains, right? So technically, every company in the world could have their own SKALE chain if everybody wanted to use SKALE, which would be awesome. That being said, not everybody is technically minded in blockchain or in SKALE technology right this second to be able to get going right away. The SKALE chain UI takes all this complexity and basically abstracts it away for the SKALE chain owner or for the user that's in charge of setting up the chain for the company or for the dApp or for the project. It does this by basically taking all the amazing smart contracts built by the core engineering team at SKALE and putting a nice GUI on top of them. I've basically alluded it to Web3 ops, so for any of the engineers here, DevOps, I hate DevOps, I'm not a fan. It's basically the DevOps for Web3. So it's kind of taking all that functionality of administering something and putting it right in your hands. That being said, the pictures are small on purpose. It's really ugly. I'm not a front-end developer, but where it's going is somewhere more along the lines of this, which is still a little bit small, but one of the product designers at SKALE was amazing, helped kind of redesign this. We took feedback from a whole slew of community members, and over the course of the next couple months, we're actually going to be basically rebuilding the entire thing from the ground up. We're going to get more community members involved, and what we're going to effectively do is build the best administrative kind of tool available so that anybody, regardless of technical ability, can come to the SKALE network, use this tool with their new SKALE chain that they just got spun up, and deploy on SKALE. And a couple more pictures. You guys can see multi-sig wallet. Multi-sig is really good for security, right? There will be a whole, currently there is an abstraction for it, but like I said, not that pretty. That's much nicer. And then scale chain manager, things like multi-transaction mode that John showed off earlier, you can actually toggle that on and off. Doing it requires touching a smart contract. In this case, connect MetaMask, click a button. So things like that can just be, abstracted away, much simpler. And lastly, just want to say thank you to everybody. It's a pleasure to speak. And like I said, these are community tools that I'm showing off. If you're a developer here this weekend and you're not really sure what to build, instead of building a dApp, try building a tool for the Scale network because there's plenty of stuff left to build. Thank you. All right, I think it's Q&A time now. So if anybody's got questions, please feel free. Any machine learning applications? That is a good question for Connor. Anybody else? Absolutely. So kind of a loaded question, but to simplify, effectively what Scale is a whole slew of EVM compatible blockchains that are run entirely by their own set of validators. There's not one validator that is run by the core team. Everything is run by external parties. Additionally, what's really cool is the Scale network actually has smart contracts on the Ethereum mainnet. Those smart contracts actually control which Scale chains are effectively using which nodes, and it automatically handles the security and the rotation and things like that. And so that's kind of the Scale network in a nutshell. It's infinitely scalable because ultimately with the external validator set, as more validators come on, right, you can basically keep adding blockchains. And because every blockchain is effectively its own blockchain, it's not necessarily contingent on the throughput capability of another chain. So let's say your buddy has an app that's doing 10 million transactions a day, but you're only doing 500. Your transactions are not getting slowed down by his chain because you're on your completely own separate chain. So that's why infinitely scalable. Just keep adding chains if we need to. Kind of two sets of security pieces here. I'll do my best to explain. I'm definitely not the expert here, but there is a huge chunk of security tied into the Ethereum mainnet contracts, from my understanding here. Additionally, there's some amazing engineering stuff going on under the hood with the BLS encryption and kind of the Scale consensus model with the external validators that effectively is another layer of security. So the side chains effectively have one layer of security, but then the Ethereum mainnet effectively acts as kind of an overarching model as well in case something did happen. It's kind of the best way I can explain it.
SKALE on an IoT network?
The specs, I would need to look. We've got it all written down. If you're interested in becoming a validator, you would speak to the man directly in front of you and myself. But yeah, there is obviously some hardware requirements that you need for that. But yeah, listed all there. Hey.
So you mentioned there's no gas fees for charging like functions on a contract. Could there be a possibility of like a malicious actor just triggering something and bogging down your DApp? Or is that
Yeah, you can do rate limiting and like DDoS attacks in that situation. So for example, like when I did my demonstration, like I did it in like different blocks. Like you can you can definitely change that. It's up to you in terms of like the rate limiting and what you want to do there. But yeah, and to prevent DDoS, that is a concern, and we don't want users to be taken away.
Basically, that was part of the reason for the S-Fuel station design is the way the smart contracts behind that are running is they actually limit how much S-Fuel can be given to any one user. So on top of the built-in rate limiting and security of the network, basically we've built a whole set of abstractions for the developer as well to try to basically limit the amount of S-Fuel a user has at any given time. Ultimately, it's technology. Someone might be able to get around it if they try hard enough, but the way... correct. So a lot of different security measures. Everything kind of stacked together makes it a pretty secure system. Anybody else? Yeah.
I'm wondering, is there any incentive reward for the validator? I'm trying to connect the benefit of becoming a validator and right now the network is gas free and where the reward comes from.
Yeah, so the validators are paid in SKALE, so that is different to S-Fuel. So essentially, what you would do is like DApp would work. We're trying to have this self-serving model as well in the future, but essentially what happens is you would pay the validators, and then they would spin up this SKALE chain, which is essentially made up of 16 nodes in that situation, and that would pay the validators in that situation. And then, Fabio, did you want to add anything?
I can hop in there. So pretty much you're prepaying for computational resources. So instead of paying as you go as gas fees and it did like kind of traditional blockchains right now, typical time you execute a smart contract, you're paying and that gets paid to the validator. You're actually prepaying for a scale chain. So you're aggregating all that computational power and then that's getting put into a bounty pool, which then gets distributed to the validators over their epoch periods. So instead of happening at that transaction level, it's happening at a rental level from the developer early on.
Awesome.
Good questions.
Yes. Anything else? All right then. Oh, yeah, go ahead. I don't think you need less nodes, you need less resources, right? So the cool part about the SKALE network as a whole right now is recently there's the hub model has been introduced. The hub model is basically shared DApp chains. So instead of, you only need 5% of a SKALE chain, you have a whole SKALE chain, we're wasting 95% of those resources as a whole, you can take 5% of a shared chain, which is a hub. So right now there's 4 hubs planned. The Europa hub, which is live, which is liquidity hub, the Calypso NFT hub, which the chain is live and it's kind of been moving and pieces are coming together, the Nebula Gaming hub, which is on the way, and then the SKALE community hub. And so let's say you build a DApp this weekend, you want to deploy it, and you fit into one of the 3 kind of areas, or you're a bit more general, but you don't really need all those resources. You can say, hey, I want to go on a hub, and you have your sliver of the resources. Awesome. Well, if there's nothing else, thank you everybody so much, and all the SKALE members and myself will be here all weekend, and please come up if you have any questions.